I came on board last year in January, and this is the first proper training session that we've held since then. So good to get in front of everyone and say hello. Just before we get properly started, just a bit of housekeeping for Eden Park here. If there's any sort of emergency, an alarm will sound and tell you to exit the area. And the assembly point here is on Ramers Ave, which is over that way, out where the main entrance is. Toilets, just out the door there and to the right. And otherwise, just sit back and enjoy. Great to have you all here again today. I'm Dwayne, who I'm sure you've all met too, sent his apologies. He had to duck out early this morning, so he should be back in an hour or so to catch up with everyone at lunchtime. But otherwise, really, I'll just hand things over to Sam. Great to have Sam from Fronius here today, as well as Dougal, who's down the back. Obviously, with the travel bubble opening, awesome to get these guys across to present what we're very excited about in the new Gen 24, which has been a few years in the making, but finally here now, and we'll have stock arriving, if everything runs to schedule, end of May. We should also have pricing out to you guys by the end of the week so that you can start selling it ahead of time. And yeah, as I say, we should enable you guys to get it all up and running and installing from next month. So I'll hand things over to Sam.
Thank you, James.
Yes.
G'day, everyone. My name is Sam from Fronius, Australia. It's always good to just come here and do this face-to-face events. I mean, last year, as you know, because of the pandemic, we couldn't come. We had to do all those virtual events, but I feel really good, excited, and just wanted to do these presentations on the Gen 24 Plus. I'm sure you guys have been waiting for this product series as well for a long time. We were going to launch it last year as well. Unfortunately, couldn't do it because of the pandemic, but now we're excited. So welcome everyone to this presentations on the Fronius Gen 24 Plus. What we're going to do in the morning session, everyone, we're going to cover the sales components on the Fronius Gen 24 Plus. So we'll look at what are the what are the features inbuilt into the Gen 24 Plus. And in the afternoon sessions, we'll have a technical sessions. Okay, so technical session will involve installations and also the commission of the Gen 24 Plus inverters. Okay, give you a bit of a background. Sam from studied in Christchurch, so originally from Christchurch. Did my engineering in Christchurch at the Uni of Canterbury. Completed my degree and moved to Melbourne 2010 and found a job with Fronius. So I worked in the technical support department of Fronius Australia. That was my first role, and supporting installers like you with all the problems faced on the site. So provided solutions whenever they had issues with the product setup or any fault with the Fronius inverters. But earlier last year, I've been appointed this new role, technical advisor. So I still work with the installers like yours, designers as well, work with them and help installers with design, system design, and also any advice, technical advice that you're looking for your commercial as well as the residential. Partners network as well. Partner network is a network of installers who are trained on our product, so they can also do the servicing of the inverters as well. So I manage the solution partner networks in Australia and also in New Zealand too. Okay, so it's been 10 years now since I started with the Fronius. So I look forward to sharing some of the knowledge that I gained over the last 9.5 years on a Fronius products. And this is our new product series, which is called Gen 24 Plus. Now, designing a new systems, whenever we make decisions to design a new inverter series, there are certain factors, there are certain things that we need to look at before we launch that new product series. Does anyone here know what's the process involved in designing a new product series? Like, what are the steps involved in designing a new systems? How do we start? What's that start process? What things we always look for? Does anyone know here? Like with any product series, I mean, customer demand. Yeah. Any other things, factors that we look at? Okay, so customer demand is probably one of the most important one. So what we always do is we also look at the market feedback as well. So as you mentioned, the customer demand, we need to understand what customers want. Okay, what are the customers' wants? What are they looking for? what are the primary considerations they make when purchasing a PV system or before purchasing a PV system. So we need to look at what are the customers' wants. First one is the customers are interested in getting a PV system because they really want to be a part of the green energy revolution. So a lot of the customers, they make the decisions because they really wanted to sort of contribute towards these green energy futures. Okay, the second wants is that they wanted to maximize their self-consumptions. Once they made the decisions to have a PV system installed, they wanted to self-consume as much PV energy as possible. So that's also one of the customers' wants. The third one is to use the energy at a later date or in the evening. So they wanted to store their energy during the day because they are not at home, they're at work, so they wanted to store their energy and use that energy in the evening. So that's also one of the customers' wants too, that we look at. Energy independence is also one of the factors, because what happens is when the grid is offline, when the grid is disconnected, so they would like to run a few circuits in the house. So they also like to achieve the grid independency here as well from their PV system. So that's one of the factors we look at. And some customers, they already got electrical cars. They also would like to charge the electric car from their PV system. So they want to use their own energy for e-mobility. Okay, so what they're looking for is a complete overall system that can communicate with all the other appliances in the house as well, okay? And also help them self-consume some of those energy produced by the PV systems. So those are the customers' wants. I'm sure you have been asked this question from your customer as well. Whenever you go and see customers, those are the questions asked to you, whether the car, it has these features available that's going to help them self-consume most of the energy. So let's look at those wants in the terms of needs, how we can actually interpret those wants in terms of needs. Okay, so what are the solutions we can provide? Whenever the customers say, I want to be a part of the green energy revolutions, that means they're looking for reliable systems. Okay, so they want to make sure the system you are installing now, it's future-proof. It's going to comply with the future regulations, future standards, future protocols as well, communication protocols. So they are looking for a reliable system. Whenever they ask the question as well, maximum self-consumption. So they are looking for options integrated into the product series for maximum self-consumptions. Does this inverter have those options so that I can switch on a specific load based on a surplus energy? I can switch on a pool pump based on a surplus energy. I can switch on a hot water system based on a surplus energy. So those are the things that they are looking for. And that's one of the solutions. And also, this question is also frequently asked as well. I'm sure most customers, they want to go with the battery options as well. So the battery connections is also important. So they go, does the inverter have a battery connections? Okay, so that solutions is also being asked by the customers. Inexpensive backup power. So they would like to run some specific loads in the house. They wanted to run the lights. They want to run the fridge whenever the grid is disconnected, right? So it's an inexpensive backup power, also integrated into the Gen 24 Plus solution. So this is also one of the solutions that we can provide to our customers to use their own energy for e-mobility. So they also wanted to know, when you install the inverter, does it have all those intelligent interfaces? What does that mean? That inverter can communicate with some of the intelligent appliances in the house. So they probably got a home automation systems, and they would like to integrate their PV systems to their home automation systems. Okay, so those are the solutions the customers also looking for, and we can certainly provide those solutions too. So I guess the overall, what they are looking for is integrated energy management system. They're looking for a complete package. Okay, so basically the goal here is to have the customer's energy needs coming from renewable sources. Okay, and those are the solutions, those are the factors that we consider when we design and produce this Fronius Gen 24 Plus inverter series. So it's a uniquely versatile, a very flexible Fronius Gen 24 Plus inverter series. It's our hybrid inverter series. So it's also got a battery inverter inbuilt. Okay, so that's the Fronius Gen 24 Plus. Now, product cycle. So the life cycle of a product is also something that we take very seriously at Fronius. So sustainability is always at our heart with what we do whenever we produce a product series, whenever we also recycle some of the components used in the inverter series. So at Fronius, sustainability is not a cliche concept. It's deeply rooted in our conduct and also our thinking and also in all the product series as well. So I'm sure some of you already seen it as well. There are a lot of the industries is also taking steps towards being a sustainable, future-proof. I mean, I've seen this ad from Coca-Cola as well. The Coca-Cola ad, if you look at it on the TV, they just marketing that as that they use a recycled plastic. Okay, so the sustainability is a very important for us as well. It's really at the heart of what we do, not just at Fronius Australia, but also at Fronius International. So what you are seeing here, that whenever we design a product, so especially with the Gen 24 Plus series, we source all the components sustainably. Okay, so all the raw materials been sourced sustainably. Then also we do is we try to use the local transport so we can further reduce our CO2 emissions. Okay, so that's also helping us to reduce our carbon footprints or to lower our carbon footprint. And whenever we manufacture that inverters in the factory, in manufacturing, we also make sure that the energy comes from the renewable sources. Okay, so in the production facility as well, we use the electricity produced by renewable sources. And once the product has come to its life, we also focus on recycling those components as well. Okay, and then reuse those components to make a new product series. Okay, so that's our goal. We wanted to make sure that we promote this sort of evidence-based circular economy. Okay, so that's definitely at the heart what we do, and it's a big thing at Fronius International and also Fronius Australia as well. So these are some of the numbers here, everyone. As I mentioned before in the previous slides, that we make sure that the energy we use in the manufacturing and productions comes from renewables. So 81% of the energy used in the factory comes from renewable energy sources. Okay, 90% of those raw materials used in making this Gen 24 Plus series is also recyclable. Okay, and as I said, we use the local transportations so that we can further reduce our CO2 emission as well, or carbon emissions. And this product is made in Austria, so it is a durable. We want to make a product that's gonna have a really good service life, so we don't have to replace it all the time. Because if you replace the inverter whenever there's an issues, it's not considered sustainable. It's not future-proof. All right, so that's why we need to make sure that the product is made in Austria, meet all the highest quality standards, so then it can last longer and we can be more future-proof and also sustainable as well. Because we don't want those parts or components end up into the landfill. Okay, that's a really big push as well, and I think we should all promote that in our industry too. Okay, so those are the numbers here, everyone's. And Fronius Gen 24 Plus series, we do have a single-phase hybrid inverter series. So here, I believe most of you are in the residential market, selling the residential and the commercial as well. If you can put your hands up, how many of you do the residential installations? And also commercial as well. Is anyone in the commercial? Beautiful. Okay, so this one here is a Fronius Gen 24 Plus inverter series. We do have a hybrid inverters for the single phase market, which is called Fronius Primo Gen 24 Plus. How many of you installed the Fronius Primo, just the snap inverters here? I think most of you have seen it, yeah, and installed it as well. So we do have a Fronius Primo Gen 24 Plus. In the Gen 24 Plus series, it's a single phase hybrid inverter series. With the power cost is starting from 3 all the way up to 6 kilowatt. Okay, it does have 2 trackers, so it has got 2 MPP trackers and a 1 tracker for battery. Okay, so we can say that it has got 3 trackers. Okay, 2 for PV arrays and 1 for battery. Okay, so this is our single phase hybrid inverter series. Called Fronius Primo Gen 24 Plus, but we do have a 3-phase hybrid inverter series, which is called Fronius Simo Gen 24 Plus. Has anyone here installed a Simo inverter as well in the Snap inverter series? Beautiful. So the Simo is always a 3-phase inverter. So whenever we see a SIMO, it's a three-phase inverter. Okay, so it requires the three phases, otherwise it's not going to work. So this is our three-phase hybrid inverter series with the power classes starting from 3 to 5 kilowatt, and also we have the bigger power classes as well, 6, 8, and 10 kilowatt. Okay, again, this SIMO Gen 24 Plus inverters has a 2 trackers for PV array and 1 tracker for high voltage battery. Okay, so we can say that it's also got a 3 trackers. 2 trackers used for PV arrays and 1 for battery input. So we're going to be looking at in the next few slides how this inverter is going to help the customers and the installers with those needs. You know, we look at what are the needs of the customers, what are the energy needs customers are looking for. So one of them was a reliable system, right? So the customers are looking for a reliable system because they wanted to make a transition towards renewables. They are ready. They wanted to just sort of, okay, we wanted to stop importing energy or drawing energy from the grid. We wanted to make sure that we produce the electricity from renewables. So once you have installed the system, they will start looking for some of the options to reduce their energy costs. Because I'm not sure here, when you feed energy to the grid, does the customers get any feed-in tariff? What's the feed-in tariff here in Auckland? There's no feed-in tariff, right? Nothing. So even in Australia as well, we used to get about 15 cents. We started with the 60 cents and then dropped to 30 cents, 15 cents, and now it's only 7 cents per kilowatt hours. Okay, so the customers are looking for those options that's going to allow them to self-consume most of the PV energy. And this energy cost is definitely one of the biggest costs for any individual, right? On their personal balance sheet, this is the biggest cost. So that's also, we want to reduce that. We're going to be looking at what are the options available that's going to help customers reduce their energy costs. But they also look for an expansion possibilities as well. So if you install the 1 inverter here now and see whether this can, you can install another Gen 24 inverters, Gen 24 Plus inverters at the same site. So what are the expansion possibility? What happens the energy consumption goes up in the future? What are the options we're going to offer them? So they're also looking for those sort of expansion possibilities. And I'll give you a quick overview what are those options as well, but there is an option to expand the system in the future. Okay, and we just wanted to help the customers produce most of the energy from renewables. This is our goal. This is our visions, right? So we want to make sure that we help our customers and also drive that visions towards 100% renewables. The other needs was that they wanted to maximize the self-consumptions. As everyone know, that they don't really get much of the feed-in tariffs whenever they feed in the energy. So what are the options available for them to self-consume most of the energy from this inverter? So there are a few options available inbuilt into these inverters. One of them is also this device we call Fronius Ohm Pallet. Has anyone seen Ohm Pallet, or has anyone installed Fronius Ohm Pallet before? Yep. Perfect. So this Ohm Pallet is mainly used to divert surplus energy to a hot water system. So whenever you are getting a surplus energy or customers getting surplus energy from their systems, you can definitely use that surplus energy to switch on a hot water systems. I mean, hot water system is also one of the biggest energy consumer, right, in the house. So we do have a device. This Gen 24 Plus is compatible with the Fronius Ohm Pallet, but it does have all the cost-effective solution as well. So it has got some of those output pins which you can use to switch on 4 specific electrical loads based on surplus energy. Okay, so it does have those pins we're going to be looking at in the afternoon sessions. I'll show you guys what are those pins used to switch on a specific loads based on surplus energy. Okay, so that's also available or inbuilt inside this inverter series. Now, battery option is also going to help customers with that to maximize the self-consumptions. So this inverter, you can connect BYD batteries to this inverter as well. So battery option is also available inbuilt. Okay. This is how it looks like if you haven't seen the Fronius Ohm Pallet before. Mainly used to switch on the hot water system or resistive loads, not the inductive loads. Okay. Also, anyone, please feel free to ask me questions. If you have any questions, we can definitely have a Q&A session throughout the presentation. So please feel free to ask me questions and interrupt me, okay? What are the battery options as well? So when we designed this inverter series, we want to give customers two options, okay? One, that you can use this inverter without battery as well. So you just connect the PV panels to this battery. So it's a without the battery. And also the easy retrofitting options also available. So if the customers in the future decides to have a battery connected, then you can certainly connect the battery to this inverter as well, okay? So you don't have to connect the battery to this inverter straight away. So there are two options, with and without battery. What batteries are compatible with this Gen 24 Plus inverter series? Have you guys heard of a BYD here? How many of you heard BYD before? Fantastic. So BYD is our battery partners, one of the leaders in making the lithium-ion batteries. They've been making lithium-ion batteries, I think for what, 20-something years, and they do make the electric cars and also electric buses as well. Okay, Warren Buffett's also got a 10% stake in the company as well, and they are one of the leaders in making the lithium-ion batteries. Okay, so those are the batteries compatible HVS and HVM. Have you installed one of those HVS or HVM batteries? Okay, with what inverter type? Was it like an on-grid system, off-grid systems?
Off-grid system with
Grid type, yeah, fantastic. So this is BYD's new generations of the batteries. So the next generation HVS and HVM, and those batteries are compatible with the Gen 24 Plus inverter series. Also, once you connect the battery, and there is a battery options available, customers going to ask you a question. Can you run some of the loads in the backup situation, right? So what happens when the grid is disconnected? So it does have a inexpensive backup functions. James will also give you a bit of an overview on the backup box this afternoon, but it does have the options to run some of the loads in the backup situations. Okay, so some of the non-emergency load you can run in the backup situation. So those are the features available inside the Gen 24 Plus inverter series. I would also like to give you a quick overview on the BYD HVS and HVM batteries. The reason why we went with this battery technologies, because it is called the LiFo. Have you heard this one here, the lithium iron phosphide? So LiFo is one of the safest lithium technologies under lithium umbrella. So under lithium as well, you got so many chemistries, right? So the lithium ferrite phosphide is one of the safest technologies that you can use in a household battery. So if you're installing it in a house, it's one of the safest lithium technologies. One of the other thing as well with this lithium iron phosphide, you can also get high charging and discharging power. Okay, you can also get the high charging and discharging cycles as well, compared to the other lithium technologies. So just compare these technologies with the other lithium technologies, and you will see those numbers are much higher with this one here. Now, this HVS battery, it comes with 2 modules and also 4 modules. Okay, with the power or energy density of starting from 5.12 all the way up to 10.24 kilowatt hours. Okay, so these are the energy density. This is starting from 5.12, 10.24 kilowatt hours, and it's a modular design, everyone. So you don't have to install 4 modules on the same day. If they install 2 modules now, and if the customers would like to sort of increase the energy capacity in the battery, you just have to retrofit those extra couple of modules in the future. Okay, so it's a modular design. As you can see, you can stack those modules on top of each other. This is the base of the battery. These are the battery modules. This is your BMS. This is the batteries management system there. Each of those modules can produce 2.6 kilowatt hours. Okay, so each of those battery modules produces 2.6 kilowatt hours of energy. Very, very easy installations, everyone, because it's a ground mount, so you can mount it on the floor. You don't really have to lift the whole thing. It comes in a separate box as well. So you just stack all the modules on top of each other. Okay, and commissioning is a much user friendly as well. So it does have the BYD BP Connect. It's called BP Connect app. You can download it from the App Store or Android, and go through some of those initial commissioning steps and commission the whole BYD batteries. Okay, so this is a HVS guide. This is a premium HVS version of the BYD batteries, but they do have the HVM as well. Okay, so as you can see from this slide, that the technology is the same. The lithium chemistry is the same, lithium iron phosphide, or we can say it's a LiFeO. They do have the 4 modules. Starting with the 4, you can extend it all the way up to 8 modules. Okay, and this is the energy density. So as you can see here, the energy density start from 11 kilowatt hours and all the way up to 22.08 kilowatt hours. Okay, again, it's a retrofitable, so you can install the 11 kilowatt hours battery now, and if the customer decides to increase the energy density in the future, you can definitely add the modules. Okay, up to 8 modules maximums here, which will give you 22.08 kilowatt hours. Again, each module produces 2.8 kilowatt hours, so there's not much difference between the other one, but it does give a bit of an extra 2.8 kilowatt hours. Okay. Yeah. It's about 25 to 30 kgs to those modules here. Yeah. Okay. So again, it's an easy installation. It's good that you asked this question because it's a ground mount system as well. You don't have to lift it. You can just stack them on top of each other. Okay, and this is your battery management system here. So this battery technologies, BYD battery box premium HVM, is also compatible with the Gen 24 Plus series. Commissioning is also the same. Just a quick note here, everyone, whenever you are using a Primo Gen 24 Plus inverter here, please make sure that you don't use this 22.08 kilowatt hours with the Primo Gen 24 Plus series. You can have a maximum of 7 modules. So that's your 19.3 kilowatt hours max. Okay, because I'll give you a quick overview on the specification as well, technical specifications a bit later on. The voltage is going to be outside of the operating voltage window of the inverter. So just a quick note there in case if you not. This is a quick cheat sheet we have got for installers, mainly used to understand what's the major difference between the HVS and HVM versions. Can anyone here, does anyone know what's the major difference between HVS and HVM? Output currents. Yeah, you can also say that output current is also one of the differences between HVS and HVM, but there is a one major difference here. And also the question is when you would use the HVS version and when you would use the HVM versions for your customers. How do you offer that to your customers? Just looking at this table. No. All right, so
the HVS can only output almost twice the power, so the batteries are parallel to the HVMs, twice as much capacity.
Correct, yeah. So what you're seeing here at the table, so let's have a look at this table, understand it. We do have this one available for installers as well in the PDF format, so please refer to that once you get a copy of that. But Simo Hybrid, which is our 3-phase inverter series, has anyone installed the Fronius Simo Hybrid inverters here? Have you seen it? There was like a one with the red cover in the front. That was our first hybrid inverter series, and it was compatible with the BYD box HV. Okay, so this is the BYD's old version of the lithium-ion batteries, but they launched this new version of the batteries, HVS, HVM. Now, if you look at this one here, this is a Primo Gen 24 Plus, and this is a Simo Gen 24 Plus inverter. So let's look at the HVS battery box premium version here. So we're going to look at the 10.2 kilowatt, and it's this table is giving us the charging and discharging power. Okay, so what's the charging and discharging power of the battery? Okay, so those numbers are the charging and discharging power. So if we get this one HVS 10.2, and we're going to pick a similar energy density or very close to this one here, 10.2, 11 in the HVM. Okay, so we go with the 10.2, 11 kilowatt hours battery HVM. And if you look at the charging and discharging power, see how the HVS 10.2 is giving us a really high discharging power here, 9.0 kilowatt. Whereas if you are going with the HVM, then it's going to give us a 4.49 kilowatt of charging and discharging power, right? So if the customers is going to run a big electrical loads in the backup situation, is customers looking for a high charging and discharging power, then we go with the HVS. Okay, so HVS is going to give us a high charging and discharging power, whereas the HVM is going to give us the high energy density. Okay, so energy is like, okay, if someone is looking for 13.8, 16.6, 19.3, 22.1. Now, if you're also looking for a high charging and discharging power in the HVM, then you're going to have to go with the HVM 22.1. So as you can see, then you get the 9 kilowatt hours charging and discharging power. Okay, so depending on that, what the customer is looking for a high charging and discharging power, or if the customer would like to run a big electrical loads in the backup situation as well, then you can consider using the HVS version. Okay, so that charging and discharging power is much higher. This is for the energy density. So energy, sort of, you can store more energy in the HVM version. Okay, is it clear here, guys? We do have this one in the PDF format, so please do refer to that whenever you need further info about the charging and discharging power. Okay. Now, what happens if the customers, they would like to sort of get more than one battery banks? Okay, because some customers, they go 22.1 kilowatt hours is not going to be enough. 19.3 kilowatt hours battery bank is not going to be enough for my energy needs. So there is an option to connect those battery banks in parallel. Okay, so you can connect multiple battery banks in parallel and use one of those Primo or Simo Gen 24 Plus inverter and have this increase the energy capacity or density further for your customers. Okay, so the parallel battery option is also available. All you have to do is you just have to update the software of the inverter. So as soon as you connect this inverter to the customer's internet, you just then do the update and it will be compatible. You can connect three battery banks. Okay, there's another table here, guys, for your reference as well. We do have this one in the PDF format too. But whenever you are paralleling those battery banks, please make sure that you refer to this table. This is the HVS version, and this is the HVM. Okay, so as you can see, you can definitely have two of those 5.1, 10.22. Three of them give you 15.36 kilowatt hours. And so on, all the way up to here. But when we go to the HVM 22.1 kilowatt hours, please note that you can only have two of those battery banks in parallel. You cannot connect three of those battery banks in parallel, the 22.1 kilowatt hours. Okay, so the question is why? Because there is, I think, the limitations with the voltage and also the current as well in the inverter. But this one here, the HVM 19.3, you can definitely connect three of them in parallel. So which will give you a total density of 57.96.
Does the paralleling of the battery banks, does that affect in any way the output current from backup circuits, or is that still controlled by
it's still controlled by the inverter. Yeah, it's still yeah. So once depleted, the other ones will kick in and then so on. So, but yeah, if the customer is looking for a really high energy density, you can definitely offer them this option as well. You can connect them in parallel. It is possible. Okay, but please note that this one here is actually not, you cannot connect three of them in parallel. Okay. Right, so the other unique features, I'm going to be covering a couple of unique features built into this inverter. Multi-flow technologies is also a very unique features that they're built into the hybrid inverter series. It was also in the Simo hybrid inverter series as well. So what it is, guys, that whenever inverter is producing energy, it can have multiple energy flows. Okay, that's why it's called multiple multi-flow energy, multi-flow technology. So when inverter is producing the AC, it can also supply that AC energy to your household loads and also feed that surplus energy into the grid. But also it can use that DC energy to charge the battery too. So that's why it's called multi-flow technologies. As you can see, there are multiple energy flows happening on the output terminals of the inverter. So that's the multiple of technologies. You may ask these questions whether it's going to work in the backup situations or not, but it does work in the backup situation as well. So if you are running some of those non-emergency circuit in the backup situations, it will also supply that AC energy to those loads and also use that DC energy coming from the PV array to charge the battery. Okay, so it does work in the backup situation as well. And this scenario here, maybe you're going to come across with this scenario as well many times in the futures where the customer's already got the existing inverter at the site, or if you are adding the SIMO Gen 24 or Primo Gen 24 Plus at the site. So as you can see, that multi-flow technologies does kick in as well when you've got an existing PV inverter, whether it's a Fronius inverter or a third-party inverter. So you can also use the energy coming from this inverter, AC energy, to charge or discharge the battery as well. So as you can see, this we are using the DC energy, AC energy as well coming from this inverter to charge the battery. And if there is a high demand from the loads, it can also discharge the battery simultaneously too. Okay, so that's why it's called multi-flow technology. It's a very unique features available in our hybrid inverter systems. Whereas if you are using an AC couple storage system, then what happens? It can only do either. So it can only either charge the battery or discharge the battery. But this is a DC couple system, DC couple battery storage systems. So you can have this sort of multiple energy flows coming out of the inverter. Okay, with that, I just wanted to also cover this one, this slide here as well. So you can connect any AC couple energy source to the inverter. So here, when you look at these sort of infographics or animations, one of the questions I got asked by customers over the phone that can you connect the wind turbine straight to the inverter or not? So this one here is showing that any AC energy can be fed into this hybrid inverter. You can't connect the wind turbine straight to this inverter terminals. Okay, so there are no terminals for that one. So this is just showing that this is an AC couple systems. You can use that energy, and how does that work? Like, how you may ask the questions, how does that work? How does the inverter know how much energy is coming from this inverter, right? So how does this inverter know? The inverter is going to know because this smart meter will know how much energy is coming from both systems. If you install this smart meter at the feed-in point, smart meter is always the feedback loop for this inverter, okay? Because you will connect the smart meter to this Gen 24 Plus inverter. So that's how it knows how much surplus energy coming from the other system. Okay?
Does the Primo inverter need to be connected to the smart meter or just the Gen 24?
Really good question, really good question. So what happened is, if you install these snap inverters with the Fronius smart meter, let's just say a couple of years ago, and now you are installing this Gen 24 Plus inverter, what you're going to have to do is, if you are installing the battery with the Gen 24 Plus inverters, you will require to connect this smart meter to the Gen 24 Plus inverters. So you're going to have to change your smart meter connections, move that connection from the snap inverters to these Gen 24 Plus inverters, okay? So Gen 24 inverters needs to know what's the surplus energy coming from the other systems or going into the grid so that it can start charging and discharging the batteries. Okay, so very, very important that you must connect smart meter to the Gen 24 Plus inverters if you are installing the BYD battery, okay?
What happens in that case when the grid goes out?
Good questions, really good questions again. So what happens is, when the grid goes out, this is not going to work because this requires always the grid. So as soon as the grid is going to be disconnected, this one will not work. In the backup situation, you can only get the energy out of the Gen 24 Plus inverter.
So in the backup situation, backup, there's going to be another box hanging off the Gen 24 directly rather than
from here, yes, yeah. So you can definitely use this non-emergency circuit here, or use the backup box. James will give you a quick overview on that as well. And that energy coming from the Gen 24 Plus used to run some of those backup loads. Okay. Unfortunately, this one cannot be used in the backup situations because it always requires the grid. And this one is not going to act as a grid for this inverter. It's a hybrid inverter, guys. Okay, so it's not going to work. All right, good question, guys. Really good questions. Thank you. So yeah, just this is an animations. It's called the multi-flow technologies again. As you can see, the multiple energy flows happening at the inverter end. And because of their multi-flow technologies, we won this award when we presented this whole package with the Fronius Simo Gen 24 10 kilowatt plus and BYD battery box HV M 11.5 kilowatt hours. So we achieved the maximum system efficiency with that package compared to our competitors when they presented those packages at the same event. So as you can see, we've been able to achieve 94% overall efficiency with the BYD and best result of all the times. So there is an article as well on our website if you would like to know how we actually achieve that efficiency, 94% with that package. Please go to our website and have a look at that articles, and it explained really well how we've been able to achieve 94% overall efficiency. Again, it's a DC couple system, so there's going to be a less energy losses, okay? Because if you've got an AC couple system, you have to convert the AC to the DC, DC to the AC back again. So by presenting that solutions at the event, we've been able to win this award at in Berlin, okay? And again, it's a maximum yield means like if you are getting a high efficiency from the whole systems, resulting in a maximum yield, which will also further increase the customer's ROI. Okay, so that's also really good for our customers. Okay, whenever we talk about the batteries, there's always going to be a question from the customers: can they run some of those load or the circuits in the backup situations? Even though we're going to get power outages, I'm not sure how many power outages you're getting here in Auckland, but still that questions do get asked by the customers, right? So I'm going to cover a few options here, a couple of options inbuilt into the inverter. And what are those options? I mean, there are many options available, but they're a bit expensive. So we wanted to sort of provide the customers with the inexpensive options so that they can run those circuits in the backup situations, how they can achieve this sort of self-sufficiency. Right, a lot of the customers, they wanted to self-consume most of the energy, and they wanted to be independent from the grid. Okay, so how we can actually help them to achieve that with and without the batteries, guys. So it does have these features inbuilt. You can have the backup functions with or without the batteries. Okay, so you probably know about these full backup options where you use the AC contactor and the relay to run some of those backup circuits, but it does have the other option called PV point. Okay, and you can use this PV point to run a single phase 3 kilowatt load. You don't have to connect the battery. It just works without the battery. Those AC terminals are already inbuilt inside the Gen 24 Plus inverter series. So it's got the normal line 1 neutral earth terminals, but it also got the AC terminals for this PV point, okay, as well. So you don't have to connect, because sometimes the customers, they may ask the questions, I don't want it to go with the battery now because batteries are still expensive, but I want to run a one specific load in the backup situations. Okay, so it depends on the sunshine. Yeah, definitely. So we're going to have to rely a bit on the sunshine as well, and how many panels we have connected to the inverter. So it's gonna rely on so that's PV power. So how much PV power we are getting from our arrays? Okay.
You have to be careful with what is connected to it, that it can handle fluctuating.
Correct. Yeah. So if the demand is if we are connecting a 3 kilowatt load and the inverter is only giving us 2 kilowatt, then unfortunately it's going to go into the overload mode. Yeah.
It's good for charging phones and small little loads.
Charging phones, or you want to plug in the fridge as well. I mean, some of the fridges are as well 2 kilowatts around that, depending on if you've got a sunny day like this today, then for sure you can connect the fridge as
If
well.
you've got, like, deep freeze in the garage,
Yeah.
typically it's gonna
Yeah.
be consuming very little power.
Yeah.
So how will it work? Will it sense the amount of draw that the load is, whatever that load is, and
Yeah.
when it knows it's above it, it'll click on and go, I can supply that.
Yeah. Yeah.
It'll turn off cleanly and it won't hurt the device.
No, it won't hurt the device. Yeah. Yeah. But important point here, guys, that it only works in the backup situations. Okay. So as soon as it detects that the grid is disconnected, then it will kick in. Otherwise, it's not going to work. Okay. So this is a very inexpensive, what we call the partial backup solution. It's not a full backup solution. It's a partial backup solutions without battery connected to the inverter. Okay, because the customer is definitely going to ask this question as well. What many installers in Australia is doing, they are installing the GPO. So they just run all those AC connections, build the GPO with the RCD, label it as a PV point or PV backup. Again, you're going to have to educate your customer as well what kind of loads you can connect, because if they are connecting a bigger loads and if it doesn't work, then you're going to get a phone call. So it's always good to just let them know that you can connect up to 3 kilowatt single phase load to that GPO, depending on the PV power.
And did you just say it will only work in backup mode?
It will only work in the backup
So if
situations.
it's not a freezer, it won't be going unless it's in backup mode. You have to unplug the freezer.
You have to unplug the fridge and then plug it into the GPO.
Okay.
Yeah.
Is it resistant or inductive load?
Well, inductive loads probably won't work because sometimes the inductive loads, they do require a bit of a higher inrush current. So it's not going to work, unfortunately, with the inductive load. So if you've got a resistive load, again, with the fridge as well, it does require a bit of a high inrush current too. But depending on that, how much is requiring, I think the fridge is maybe if it's got 2 kilowatt, and if you are getting a 3 kilowatt from the inverter, it should be able to handle that. Yeah.
So even if you've got a 10 kilowatt three phase SIMO, it's still only going to be able to put out.
Single phase, yeah. This is only for running a single phase load, and it's not going to run the 3-phase load on the PV point. So it's only 3 kilowatt single phase. Okay.
If you've got two 10 kilowatt inverters installed, you'll be able to run
Two,
two lots of three.
two, yeah.
Would it run a small water pump?
Water pump as well. Again, it's depending on the specifications and also the power rating, because I had installers call me and he's connected the water pump in the backup circuit and it wasn't kicking in as well because it was requiring a high startup current. So as you know, that some of the motors, they do require 5 to 10 times more startup current. So in the beginning, they do really need the inrush current. So unfortunately, the inverter cannot supply the inrush current. So it may not work. Inductive loads generally not recommended, but if the specifications are within this output of the inverter, then you can certainly try that. Okay. So this is an inexpensive solution, guys. This is how it works. As you can see, as soon as the grid is disconnected from the inverter, it will go into this mode and start supplying the energy, AC energy to that PV point, and you can connect any loads to that. But also it can charge and discharge the battery as well. So again, this option here, if you got a battery connected here, you would rather implement the full backup options. Okay, so most of the installers in Australia, they are just doing this PV point when the battery is not connected. Okay, so but that option is there as well if you got a battery connected there, and it will still supply the energy to this PV point. Okay, this is the full backup option. So most of you already done it. This one, if you install the hybrid inverter series, has anyone done the backup functions with the Fronius SIMO hybrid or any other brand? Have you guys? You've done it? Yeah. So we do have that full backup options available as well with the Gen 24 Plus inverter series. As you can see, this is for the SIMO 6 to 10 kilowatt, but we also have that options inbuilt into the Primo inverter, Gen 24 Plus inverter too. Okay, we can say that it's gonna supply most of the circuit, especially if you are using SIMO 10 kilowatt, because SIMO 10 kilowatt can output 9 kilowatt. Again, it depends on what's the inverter size and also what's the battery size as well. So it can output 9 kilowatt. Okay, so if you've got a 3 kilowatts backup circuit per phase, again, if you got more than that, it's going to go into the overload situations. Okay, so the 9 kilowatt is the max you can get out of it from the SIMO 10 kilowatt. With the single phase Gen 24 Plus, the output is always depends on the nominal capacity of the inverter. So if it's a 6 kilowatt, it will output 6 kilowatt in the backup, depending again on your battery bank as well, how big your battery bank is, right? Okay. So what's the switch over time? It's less than 60 seconds. So as soon as the inverter detects that the grid is offline, grid has been disconnected, it's going to take 40 to 60 seconds to go into the backup mode. Okay, so there's a bit of a delay there, 40 to 60 seconds to go into the backup mode. You can certainly run the single phase and 3-phase load in the backup situation if you are using the SIMO Gen 24 Plus inverter, as well as help them achieve this sort of self-sufficiency. Okay, you may have heard of this term. It's going to be used a lot in our industry as well. It's called self-sufficiency and also the consumption rate. Okay, self-sufficiency means they are becoming a more independent from the grid. Okay, so this is also
see the level of the battery storage for self-consumption that leaves, say, 30% for...
Absolutely, yeah.
Okay.
Yeah, you can definitely have the reserve capacity for the backup function. So if you would like to reserve some of the battery energy density, 30%, whatever you would like to have, you can definitely do that as well. Set that figure on the inverter's interface page.
So
Okay.
it's not just a matter of setting a DoD for regular use and then a backup?
Backup as well, yeah.
Separate.
Yeah, definitely. For sure.
Is that something that a customer could do? Or like if they, so I know the Tesla one is now saying that if the storm's coming, they'll automatically top up the battery and to go through a night expecting maybe a power out.
So depending on if the customer is specifying you or the installers that they would like to have a reserve capacity in the battery just in case if there is a power outage, then you can set that figure there, 30%, 40%, 50%. So then for the regular use, it will deplete to 50% and it will reserve the 50% capacity for the backup situation. Yeah. No, cannot be easily changed. Yeah, because it's also password protected, depending on whether you want to give that password to the customers or not. So we'll be looking at that in the afternoon sessions. I'll show you guys where to set that value on the interface page of the inverter. Okay, so that's the maximum backup power functions. Good questions, everyone. Again, the way you implement that is you're going to require AC contactor and the 12-watt relay as well. So we're going to give you a very detailed overview on how to implement the backup functions. But this is how it works. As soon as the inverter detects that the grid is offline, it will go into the backup mode and start supplying energy to those household loads. Okay. And also it can charge and discharge the battery as well. So multi-flow technology is always going to kick in whenever there's more energy required, it will start discharging the battery and start supplying that AC energy to those backup loads. Okay. All right, so third party and e-mobility. So it's also a big topic here as well. Even in Australia as well, we've seen quite a few electric cars hitting the road too. Here as well, you've probably seen a few Teslas running on the road as well. So the customer's also going to start asking those questions, whether they can charge the electric cars from the PV systems or not. Or the other questions they may ask, whether they can integrate this system to their home automation systems. Okay, so this inverter is packed with all those open interface protocols. Okay, open interface is nothing but it's a communication protocol. So we have given installers or the customers the ability to connect these inverters output or all the system values to their home automation systems or any third-party device that they are using in the house. Okay, so that's also inbuilt. Different EV charging stations is also compatible as well. So there's one universal EV charger. You can always use that as well. We're going to launch the new product called Fronius Watt Pilot as well, which is our new EV charger. But it's coming out end of this this year. So we'll talk more about that end of this year. Okay, so there's a new product coming up too. So again, it's also going to help customers achieve the maximum energy self-sufficiency as well, because if they can connect to a home automation systems, they can definitely set the time of usage, when they're going to switch on the specific load, when the PV is producing the maximum energy, so they can also do that kind of smart interface with these inverters integrating to those home automation systems. Okay.
Is there a list of the different home automation, or is it just everything?
Depending on what protocol is used by the home automation system. So those are the interfaces we got inbuilt. So LAN, WLAN. So we also have the Modbus RTU and TCP SunSpec. So it's always good to know what are the communication protocols used by that home automation systems. Okay. What we found is the Modbus TCP and RTU is the most common one used in a building management system. So have you guys heard of this term here, Modbus TCP RTU? Basically, this used it's a communication protocol. So it's used to extract some of the inverter values and upload those inverter values or PV system values onto their portal. Okay, so if you look at the big commercial property, they do have the building management systems where they can monitor the air conditioning's output. They can also monitoring other electrical loads as well on their own portal. And if they would like to integrate some of the values coming from the inverter, they can also do that too using these protocols. Okay, it does have the digital IOs as well. So if there is a third-party controlling device used to ramp up and ramp down the inverter's output, you can also use those digital IOs to control the inverter's output. So there are certain third-party controlling device compatible with our inverters. Some of the installers, they do use it in Australia, but this also available here inbuilt into the inverter. Fronius Solar API is also going to be another topic and another term that will be used in the industry as well. Has anyone heard of the Fronius Solar API as well? It's internet-based as well, using the JSON protocol. So we won't talk about it now as well. It's very new as well in Australia, but it's also inbuilt Solar API. Okay, mainly used in a virtual power plant and VPP and those sort of applications. Okay, so it has got all those interfaces available if the customer would like to extract some of the values and upload it to their own portals or platforms. Okay. With the energy management, as I mentioned before, that there are some inputs or output pins that you can use to switch on a 4 specific loads. So it does have the capability to switch on a 4 specific loads based on the surplus energy. Okay, so we're going to be giving you a quick overview on that one a bit later on in the afternoon sessions and how to do that. But if you would like to switch on a 4 specific load based on a surplus energy, you're going to have to install the Fronius smart meter. Okay, because without the Fronius smart meter, inverter doesn't know what's the surplus energy going into the grid. So you must install the Fronius smart meter to implement this energy management function with the inverter. Okay. All right. So any questions so far, everyone? Those are all the features that we covered: energy management functions, open interfaces, multi-flow technologies, backup functions. But in the next few slides, I'm going to give you guys a quick overview on the technical specifications. Okay, how many panels you can connect to this inverter, how many strings you can connect to this inverter. So we're going to be looking at the Fronius Primo Gen 24 Plus inverter. As I mentioned before, it comes with the power classes starting from 3, 4, 5, and 6 kilowatt. And as you can see here, the MPPT's got a very broad voltage range as well. The startup voltage is only 65 volts, and the maximum voltage is 600 volt DC. Okay, so as you can see, it's got a very wide MPP voltage range. You won't have to connect many panels in series to switch on the inverters. You can connect up to 3 modules to run this inverter now as well. So what's the common panels size used here? Is it 350, 370 watts? Have you guys?
Sort of 320 through to 400.
400 now as well. So as you can see, the panel size has also gone up as well. In Australia, the most common panel size they use is 390 watts. It used to be 370 watts. So we're slowly making a transition towards also bigger panels too, 400. I heard there's a 470 or 480 watt panels coming out as well soon, end of this year. Okay, so you don't have to connect many panels in one strings to run this inverter because the startup voltage is very low. Okay, the other really cool thing here as a solar designer, that as you can see, the current rating for tracker 1 is 22 amps. Okay, so if you are a designer, if you're designing a system and if you would like to connect 2 strings to that tracker, then you can definitely do that as well, because it's got a high current rating for tracker 1, whereas the second tracker you can have 1 string connected because it's got a 12 amps current rating. Okay, so great flexibility, and we have been able to do that, and I'll mention why we have been able to achieve this sort of high current rating a bit later on. But that's also a very flexible if you are designing a system with the 2 strings combined on the roof. Okay, it offers a great flexibility whenever you're designing a systems. And oversizing, guys. This question is also do get asked as well, how much of oversizing you can do, how many panels you can connect to this inverter series. What's the oversizing ratio? So you can connect up to 150% of the nominal capacity of the inverter. Okay, so if you are, for example, installing a 5 kilowatt inverters, you can connect up to 7.5 kilowatt of PV to that inverter. Okay, so it's 150% oversizing. Many installers, they do prefer oversizing because it's a DC coupled. So if you are installing a battery at the same times, it's always a good practice to put more panels, because some of this DC energy will be used to charge the battery, right? It's a DC coupled battery. So good practice to oversize this inverter too. Similarly here with the Simo Gen 24 Plus, everyone, because it's a 3-phase inverter, as you can see, the power class is starting from 6, 8, 10. The broad voltage range again as well, 80 to 800 volt. So 80 to 800, 1000 volt DC is the maximum. In the Primo Gen 24 Plus series, as you can see, the maximum voltage is 600 volts. So I think installers here, or there is a regulations that if you are installing the inverter in a residential property, then we got a 600 volt limit there. So there shouldn't be any issues with the Primo snap inverter. Snap inverters, we had like 1000 volts. So installers had to sort of make sure that it's below 600 volt DC. But with the Primo Gen 24 Plus, the maximum is 600 volts, so it shouldn't cause an issue. But with the Simo, we do have the high voltage here, 1000 volt DC. Again, you can connect 3 modules in a string and run these inverters. As you can see, the current rating as well, you can connect, you can definitely combine 2 strings, because the maximum current it can track is 25 amps, okay? And 12.5 amps for the second tracker. The battery input is 22 amps. Again, the output is going to be 22 amps as well. So that's the current specifications for each tracker. Okay, please ignore this comma here. I think comma is a decimal point in Europe, so they use a comma, so it can be confusing. Okay, so that's the 12.5 amps. Alrighty, again, the 150% oversizing as well. So if you are installing a 10 kilowatt systems, you can connect up to 15 kilowatt of PV to this 10 kilowatt inverter. So 150% oversizing is possible too. This inverter, these are the classes. This is again a Simo Gen 24 Plus inverters with the lower power classes, starting with 3, 4, and 5. Broad voltage range. The voltage range again is the same, but please note, everyone, that the MPPT current rating for each tracker is 12.5 amps. Okay, again, so this is the point here. So 12.5 amps per tracker. Okay, that's the major difference between the 6, 8, 8 compared to this 3, 4, and 5, because it's a smaller power classes. So there is a bit of restrictions in terms of connecting 2 strings to tracker. Okay, but I'm hoping that we won't be connecting 3 strings to this inverter, especially if it's a 5 kilowatt. Generally, I think we do have 2 strings max, but if you have more than 2 strings, probably won't have that scenario at all. Okay, very important point here again as well with this Simo Gen 24 Plus 3, 4, 5. We cannot do the full backup functions. There's only a PV point options available. Okay, so please note that with these smaller power classes in the Simo Gen 24 Plus series, there is no full backup options. There's only a PV point options available, okay? Because we thought that with this sort of power output, you probably won't be able to get much out of the inverter anyway in the backup situations, okay? Yeah, especially in the three-phase installations, you really need a high power in the backup situation. So that's the reason why there is no backup options available. Yes, Rod?
I just wanted to mention, Taspac won't be pulling in the SIMOs for the New Zealand market. We'll be stocking the Primo series only because of New Zealand's per-phase metering. It doesn't work with battery banks in New Zealand. So just keep that in mind. It's good info to know on the SIMO, ready for the rest of the world, not for New Zealand and Czech Republic. So just keep that in mind with the SIMO. So we won't hold stock of the SIMO. We can get them in, but
factory in depth globally, so we have to get them across to Australia if we do. So just allow us a couple of weeks for that if you do need one for a certain application.
So is that because it won't provide an unbalanced output?
No,
In three-phase?
per-phase meter invoicing in New Zealand. You'll be discharging your battery for 8 cents and you'll be charged 33 cents.
Because it's a balanced output.
It's not metered invoicing in New Zealand or Czech Republic.
Yes,
Because the inverter's got to inject symmetrically.
Yeah.
Yeah.
It's going to be symmetric across, symmetric input across all phases.
Output process.
Yeah, that's right, from the inverter. Yeah. So it's only Czech Republic and New Zealand affected by it, so you'll be dumping your battery. Issues I've had with this before is the power bill stays the same or the power bill increases. So keep that in mind with battery hybrid on three-phase. The only way around it is single phase times three. 3 separate battery banks, 3 single phase inverters, but you won't get a three-phase output with grid failure. So unless, look at the loads if they're balanced, but most properties you'll see connected to three-phase, they don't even use one leg, or they use it for water pumping or hot water or something. So you just be very careful with three-phase battery systems.
Yeah, it is a bit unfortunate here as well that you have to use a three inverters for a three-phase supply. I think, but in Australia we don't have that kind of regulations or standards. So installers, they just install the Simon Gen 24 plus 10 kilowatt, and even with the export limit as well, they can certainly install the Simon Gen 24 plus on a three-phase property. So they're unfortunate, but thanks Rod for mentioning that.
I've just got a question on the oversizing. So if you put 150% PV on it, what's the energy flow like in good conditions because the battery is DC coupled? So you're going to say if it's a 10 kilowatt inverter and you've got 15 kilowatts of PV on, is the 10 kilowatts into the AC network as well as
the DC energy coupled? Yeah. It won't be full 5 kilowatt of the DC, depending on losses. Yeah, definitely. So this is the reason why a lot of the installers, they're like oversizing this hybrid inverter, so that they can use the DC energy to charge and discharge, or mainly charge the battery as well. Yeah. And this is the reason why we went with the DC couple options, not the AC couple, because then with the DC couple battery, there are less efficiency losses as well. So you don't have to convert DC to AC again and AC to DC again. Okay. All right. So the other really important topic and really big talking point in Australia is about the shading as well. So shading is a very a topic that's talked about a lot in Australia. But just wanted to give you a quick overview on this. There is an inbuilt feature in the Gen 24 Plus and also in the Snap Inverter series. It's called Dynamic Peak Manager. It's nothing but what I want to say is it's a shade fix management. So whenever there is a partial shadings on a string of the panels, then these features will come into play. Okay, so there's always been a lot of confusions and also a lot of misconceptions in the industry as well. How does that work? How is going to affect the panels output? How is going to change the stringers output as well, and how it's going to work. So basically the way it works is, everyone, whenever there is a shading on some cells of the panels in the strings, what will happen is that this curve is going to get distorted. Okay, so on a nice day we'll have a nice bell-shaped curve, but as soon as there is a shading on one of the panels in the strings, this curve's going to get distorted. So sometimes the inverters can get stuck here. The inverter's MPP tracker will get stuck here. But I'll show you guys that graph. This is much easier to understand. As I mentioned before, that on a nice sunny day, you get this beautiful, beautiful bell-shaped curve. This is a power versus voltage curve here. So this is a scenario where there is a shading in the morning at 9 a.m. and there's a shading at 8 a.m. So what happens when there is a shading on one of the panels? So as you can see, that this whole curve gonna get distorted. So it will produce those two peaks. Okay, as you can see, there's two peaks here. Every single inverter, what they do is they scan this curve here. Okay, every 10 minutes. So if that inverter is scanning this curve here, it can get stuck here if this one doesn't inbuilt, if this feature is not inbuilt. Okay, it thinks that this is where we are getting the maximum energy from that string. So this is called the local maximum power point. This is called the global maximum power point. But the maximum energy that we are getting is at this point of the curve. Okay, so with these features inbuilt, our inverters always locate the global maximum power point whenever there is a partial shadings. Okay, and by doing that, we are able to get more energy out of the whole systems. Okay, so we have got a white paper here as well. As you can see, we tested this on a 3.3 kilowatt peak systems in Central Europe with the panels facing southwest. Again, it's in Europe, so it's going to be facing south. Tilt angle is 19.5, partially shaded, and we've been able to achieve 7% higher yield using this dynamic peak manager function. So this is without the dynamic peak manager. As you can see, we are not getting energy, so we are losing the energy on this part of the curve. But with the dynamic peak managers on, we can get this extra energy out of the whole systems. Okay, so we've been able to get 7% higher overall on that day. Okay, now how do you understand that? Because the shading is a topic that sometimes not easy to understand. You may have seen it as well. How many of your, I guess, installations here have a shading? Do they have a shading at all? Or what percentage of your installations? All the times, yeah, all the times from antenna or something. So, partial shading. So partial shading is defined whenever few cells of the panels are shaded for a couple of hours. Okay, so early in the morning, maybe late in the evening. So how does that work technically? So imagine this is a one string where we got 5 panels. So the myth in the industry is whenever these panels got a shading, it's also going to affect the output of the other panels in the same string. Okay, so that's what that's the conception is in the industry sometimes, but it's not true, because if you look at this one here, whenever some cells of those this panel here shaded, what will happen is the bypass diode is activated. Okay, so everyone knows that panels got a 3 bypass diodes. All the panels, they've got a bypass diode to overcome these sort of situations. Okay, so whenever there's a partial shading, what will happen is the bypass diodes is activated. Let's consider the scenario where there is no shading. Okay, so let's just say the leaf node here, under no shaded conditions, the current will from here. So the current is going to have this sort of path like this here, and also add the voltage of each of those cells. Okay, so you get 100% of the power. But what happens when there is a shading on some of those cells? This one will be activated, so the current is going to take this path here. You start adding the voltage of those cells, and you will lose only 33% of the power from that panels, but other panels will still give us 100% of the power. Okay, so this is how it works, everyone, because if there's a shading, there's always a bit of a questions about how does that work, how does the current travel through that channels or through that panels, what's the resistance, what's the power, what's the voltage. But it's very easy to understand. Those cells are connected in series, so those cells are connected in series. Whenever there's a shading, there's going to be a high resistance. This one will be activated, and the current is going to take this path here. So you're losing a bit of a voltage, but the current stays the same. Okay, what will happen is the questions if these cells are shaded as well. What will be the output of these panels, everyone? If this, so 33%, right? Perfect. And what will happen is if all these ones are shaded as well, just get bypassed, right? So the currents, all those bypass that is going to be activated, and the current is going to travel from here, and then again with those panels. So that's how it works.
There might be some confusion here because
Yeah.
everyone in this room's probably seen the same picture of that maple leaf covering the whole panel by another microinverter manufacturer that say that you get a maple leaf on and the whole string collapses. So it's just taking the fallacy out. That's why there's bypass diodes and inverters, and this is how a string actually does work. So.
Mm.
And it's a really big maple leaf.
It's a really
Or maybe small. So that's why some of those cells are probably covered as well. But what will happen is with that, just the voltage will get affected. So because this voltage, we are not getting the voltage from those cells, but we do get a current here as well because the series connections. So the voltage will get reduced. As you can see, the voltage is going to drop. But whenever there's a shading, this curve is going to get distorted. These features will kick in and give us a bit higher energy yield in a shaded conditions. Okay. So we want to make sure that the MPPT tracker is not going to get stuck here, because if it's going to stuck here, then we're not going to get high energy yield. Okay. So this dynamic peak manager always find this global maximum power point. Okay. So that was the other features. The other feature inbuilt into our inverter is the active cooling technologies. Okay, we strongly believe that having a fan in the design of the inverter is very, very important, very critical, because power electronic components in the design of the inverter, they work at a high DC voltage and also high DC current. So we strongly believe that we need to have active cooling technologies in the inverter. Active cooling technologies means the fan in the design. Okay, some of the inverter manufacturers, they've got a heat sink to dissipate the heat, but we always believe in active cooling technologies. Even if you look at our IG series, IG Plus series, all those legacy products, they all had the fan inside the inverter series to dissipate the heat. Because as you can see, those power electronic components, they do the high frequency switchings, they work on a high DC voltage, high AC current, so that heat needs to be dissipated properly. If you do not dissipate the heat properly, then it's going to affect the life of the components. Okay, and that's the most difficult part of designing an inverter, how to dissipate those heat properly on the printed circuit board. Because if you don't do that, those components are going to experience a failure at some stage. Okay, so that's very flexible. We always believe in that. This Gen 24 Plus inverters as well, it has got a fan in the front. It looks a bit bigger compared to the Snap inverter series as well, so it may give you a bit of a fright how much of a noise it's going to make, whether it's customers going to feel a bit annoyed about the noise coming from the inverter. But it's a new technologies, new fan use as well, so it's not going to create as much noise. Okay, so it might give you a bit of a fright, but it draws the cool air from the front and dissipate the hot air around the inverter.
Did you say that it was quieter than the Snap?
Quieter, and yeah, you probably, I would say it is much quieter compared to the Snap inverter series. Yeah. It's a different fan as well, and different technologies we use. And one of the biggest benefits we've been able to get out of this active cooling technology is whenever there's a fan, the inverter is going to start derating at a much higher ambient temperature. Because in Australia, we got a very high ambient temperature, especially in Queensland and also Perth as well. So if someone installed the inverter in a west-facing wall and it's been exposed to the sun for a few hours, the inverter is going to start derating at a much higher ambient temperature. Whereas if you've got a passive cooling means the inverter has a heat sink, okay, not the fan. So it's going to start derating at a much lower ambient temperature, around 30 and 35 degrees Celsius temperature. Okay, so these are the main benefits we've been able to achieve through that active cooling technologies as well. All right, so those are the slides that would like to cover with you, share with you all in the next sections of the presentations, Dougal will give you a quick overview on how to analyze the system values, how to understand some of the system values on our monitoring platform. Okay, how many of you been using Solar Web platform? Have you all used the Solar Web platform as well? You always connect the system to the customer's internet and get it online, so that, yeah, fantastic, great. So Dougal will give you a quick overview on how to analyze some of the system values. Would you like to use this one?
Sure.
Yeah.
I'll use that one.
Is there the power consumption of the inverter itself with that fan?
With the fans, so the efficiency, again, it depends on the efficiency of the inverter. So this is a transformer-less inverter. We can get up to 98% of the efficiency. So again, the efficiency depends on your DC voltage. So if you look at the efficiency curve, what voltage you're getting from the from your PV array, then it will produce the maximum efficiency. So it always depends on the DC voltage. Higher the DC voltage, the better the efficiency of the inverter is, especially with our inverter, because then it doesn't have to boost the voltage or buck the voltage. Do you want to?
I'm all sorted.
Sorted? Fantastic.
Hi guys, for those that haven't wandered out to go to the bathroom. My name's Dougal. I'm the National Distribution Manager of Fronius. I've been slinging solar for about 10 years. I actually worked for a Fronius authorised sales partner for 7 years, then made the jump over to manufacturing about 3.5 years ago. I spent a lot of time with Dwayne doing forecasting and stuff like that. Before I get stuck into the next part of the presentation, though, we've got a bit of marketing swag here and some questions. So I'm going to ask a few questions. Raise your hand. I'll pick a raised hand. If you get it right, you win something. Yeah. So first question is, what is the backup switchover time on the Gen 24 Plus? Ooh, right there was first. Correct.
Okay. Let's see. Pair of sunglasses for you.
Well done. What's that say, Dwayne? Oh, ACR. What is the maximum single-phase Gen 24 Plus AC output? 6 kilowatts. This next one's easy, so raise your hands rather than shouting it out. What is the maximum output of the PV point? Yep, correct. This one's hard. Dwayne, this is hard. What are the MPPT current ratings on the Primo Gen 24 Plus? Close enough, 12.5, but we'll take it.
All right. So polo shirt for you. Medium, large, or extra large? Probably not extra large.
Medium.
Yeah, medium. Sure.
And lucky last, what is the max percentage oversizing on? Yep, 150. Oh, the T20. I think we might need that. Oh no, James has got one, don't you, James? You still got one, James? Yeah, good. All right, so we've had a bit of an overview in terms of the Gen 24 Plus and spot prices after lunch. There'll be more prices after lunch. So we've gone through some of the tech specs, bit of information around the Gen 24 Plus. One of my roles and a key role I have is forecasting demand. I often get foiled by shipping delays and the like, but generally we try and get as much product into the country as we can. We saw before that the Primo Gen 24 Plus comes from power classes from 3 kilowatt to 6 kilowatts. Do you guys foresee much demand for 3 and 4 kilowatt models? No, not really sure. A bit of a maybe. So at the moment, we're primarily bringing in the 5 and the 6 kilowatt. So if you do find a customer that wants the smaller system, wants the Gen 24 Plus, and you think a 3 kilowatt's going to be the right one for them, just let them know it might be a slightly longer lead time, because we'll have to find another way to get you one. Just a bit of a startup.
Lead times we've already got through.
Yeah.
But I'll just let everyone know I was actually outside Fronius's control.
Yeah, the shipping delays have been a bit of a nightmare for us. All right, so I'm going to give you a bit of a rundown around Fronius SolarWeb. Who here already has a SolarWeb account? And most of you do. Who here already has the SolarWeb Premium account? A couple of people. Now, it would be the free one, I'm assuming, rather than the paid one. Yep, you got the paid, Cyril. Oh, good work. We have launched quite recently a paid version of SolarWeb. It's SolarWeb Premium. It gives you more advanced features that you can use to help sell additional functionality to your customer. So it's worth it. I don't think the customers need SolarWeb Premium. I think the free version is fine for them. But as an installer or an installation business, would recommend that you spend the $39 for a year subscription. It's not a lot of money. You'll actually find there's a lot of features in there that'll help you sell. I'll run through some of those. So SolarWeb itself, it's obviously very user-friendly. You've all used it. You know what it looks like. You can get actual information out of it, like proper, real data. It's got a really easy consumption analysis tool in there. You guys get automatic notifications into your inbox if something goes wrong. You can do your software updates from SolarWeb. And I reckon, and Fronius really does believe, that the smart meter goes with SolarWeb like, you know, just they peas and what do peas go with? Carrots. Smart meter, it's kind of like if you don't have one, you're driving a car without a speedo or a fuel gauge. You don't know what's going on with that solar system. SolarWeb and a smart meter will give you a lot more information with the smart meter than you'll have otherwise, and you'll be able to do a lot with it. I'm going to skip through these and come back to them because they're slightly out of order. And I'm going to skip through that one too. All right. So everyone's installed a smart meter before or sold one, I'm guessing? Yep, cool. This will be pretty straightforward then. Single phase, there's two versions available. The straightforward one's the 63A-1. The -1 is single phase. It's DIN rail, 2-pole. It's direct connect, and you don't need any CTs. It's pretty straightforward. There's also a flat pack wall-mounted one. If there's not enough room in the switchboard for the direct connect, you can buy the UL240. It uses CTs, will give you exactly the same data that you get from the 63A-1. The 63A-1 is the one that's most commonly going to be used. In the 3-phase, and this is across the broad range, you've got the 63A-3. Again, DIN rail mounted 2-pole. You've got a 50 kA for those that need more than 63 amps, where the circuit's greater than 63 amps in the house. And you've also got a flat pack one, the 480 UL. Both the 50 kA and the 480 use CTs. You will need to source those CTs separately. We're currently investigating a Fronius solution for the CTs, a Fronius branded CT. Should have that hopefully within about the next 6 months, so that might make purchasing a bit easier.
Wide range of CTs
available
at Taspac anyway.
Yeah. So SolarWeb, you've all seen it. Basically, you go there, you log in. If you don't have an account, click the register button and you're away. This is what you're going to see when you log in. If you purchase the premium version, you're going to notice that down here in the bottom right-hand corner, there's a weather forecasting. And this is one of the first functions that you get with the premium version. It's a weather forecasting tool. And it will actually give you what the expected yield is going to be for the next 2 days. So a really useful way for your customer or for yourselves, if you're going to go back and sell to that customer, to be able to understand what they're going to expect over the next couple of days based on the weather. The energy balances that you'll see in SolarWeb will also be slightly different. On the left-hand side there, you can see it's got the production curve, and the second half of the day, it's forecasting what that production curve will look like based on the weather forecast. If you just clicked on the consumption, it would remove that and you'd still have all the rest of it. This is a fairly busy graph, but you can see in here they are charging a battery. That's the green. The yellow is the self-consumption. It has a line for the state of charge. As soon as we get up to the top here and the battery is full, it starts exporting to the grid. So it's a really good visualization for your customer to understand what is happening with their solar system. Forecasting, you can see the next couple of days of production. You can also have a look at that view from a monthly basis. It doesn't have to be a daily. You can go back to monthly. You can go to yearly if they've had the solar system for a while and really get a comparison as to what's happened over the course of time with this solar system, what they've self-consumed, what they've put into a battery, what they've taken from a battery, what's pushed into the grid. It's all available in SolarWeb. SolarWeb Premium also gives you and your customers a couple of extra functions, which I think you're going to find really useful to help sell to your next customer. This is where having a SolarWeb account where you're the premium owner, asking a customer, hey, would you mind if I just use a couple of your graphs to help me sell to my next customer? You can walk into a sale and say, hey, I did an install a couple of months back. Have a look at this. The return on investment is one of the graphs that you'll get. And this will actually show the amount of money that has been saved by that customer on a monthly, yearly, or daily basis. You can also see, and this is probably even a better one, the expense, so the actual savings that that customer has. So the top of this pie chart is the total electricity cost. With solar, you've now saved all that green bit, and this is your expected bill. Now you need to enter in the energy tariffs. You need to say they're paying 25 cents a kilowatt hour, whatever it might be, for this to work. But it's pretty straightforward to key in at the front page. If you take that to a customer and you can show them, hey, I did this 6 kilowatt install down the road, have a look at the amount of money they're saving. You too can save this sort of money. Customers are going to jump at this. You can just use your own SolarWeb account with the permissions set so you can view all your accounts. You also get analysis features within SolarWeb. Now, the standard free premium version has analysis functionality. The premium paid version has even more. So you just go into the history, you select the inverter that you wish to review, and you can now click on whatever channels you really want to see. So this one, we've already had a look at the graphs of consumed directly, and we saw this before with the general view. You might also want to do a bit of troubleshooting on a system and go, I want to know what MPPT1's voltage was over time. You can just select the voltage that you want or the current that you want on that tracker, and it will spit it out for you over a period of time. And this is super useful if something's gone wrong, or the customer rings up and says, hey, my solar's not working. You might be able to jump in here and have a look and go, oh, the grid voltage jumped up to 260, and so your inverter turned off. A really simple way to not have to go out to site and find out what's going on. Another feature for SolarWeb Premium, we talked before about some of the integration with smart homes, Amazon Alexa. You can actually connect it in, say, hey, Amazon, what's my solar system producing today? Amazon will just tell you. The Alexa will just say, hey, yep, you're producing 3.4 kilowatts. Bit of integration there, but it's a bit of fun. Some people love the smart home stuff. This one, I think, will really help you sell the Gen 24 Plus, particularly if the customer doesn't want a battery straight up. Now, you guys all currently doing hybrid systems with batteries? Not yet, some nodding. Yeah, okay, cool. So from the homepage, you can jump in to a couple of simulations up there. There's a battery simulation. The first option you'll have, there's two options up here, is heating or storage. Now, if you're running the simulation on heating, it's going to say, okay, what would happen if we added a hot water diverter in the form of an ohm pilot? What's that going to do to my self-sufficiency? So you'd be selecting where they're getting the heating currently from. Is it gas, is it electric, what they're paying for it. Click the simulate button, and it will actually say, okay, if you added an ohm pilot and you diverted all this surplus energy that you have during the day into your hot water tank, what does that do to your self-sufficiency? And you can see it increases, and it'll show you how much it increases over time. You can also do that with the battery. So you just click on the storage one. First one, we've got backup mode turned off. We talked about keeping some reserve capacity in a battery earlier. So the backup mode's turned off. Again, you say, what happens if I add a BYD 22 kilowatt hour stack? And it will tell you, and your customer, what will happen to their self-sufficiency. Now, this is useful if you've installed a Gen 24 Plus without a battery. You've got the data through SolarWeb as to what they've used over a period of time. And you think, I want to go back to this customer and try and sell them a battery. I'm going to convince this customer to part with a bit more cash. They really should put a battery in. You could run this simulation for them after 6 months and say, hey, if we installed a battery now, this is how much will increase your self-sufficiency. You could use an existing SolarWeb account that's maybe just got a snap inverter on it, and you want to go and install a second system with a battery, with the Gen 24. You've got all the data there. You've probably got a year's worth of data. You can use that to say, hey, if we install Gen 24 as well as your existing system, this is what we can do to your self-sufficiency. Sam?
Sorry to interrupt there, Dougal. Just wanted to quickly mention here, everyone, this is a fantastic tool if you would like to run simulations on all your systems. So I believe you all register your customer system under your account, you're monitoring it, but this is an analytical tools already inbuilt on the platform. So you go to the analysis, you start the simulation, select the storage, select the battery size. It gives you the self-sufficiency rate, self-consumption rates. Now, these are the real data, everyone. So the real data coming from the customer systems. So if you install the Fronius smart meter with the snap inverters, and those data are used or stored in our server, and we run the algorithm, and based on that, it gives you this self-sufficient rate and self-consumption rate. It's not based on some assumptions. These are the real data. Okay, so there's simulations. Please note though, it only works if you install the Fronius smart meter. If you haven't installed Fronius smart meter, it's not going to give you this kind of results. Okay. Other thing, as you can see, everyone, it's also showing what months or which months of the year they are going to be self-sufficient. So yellow means those are the months they're going to be self-sufficient. The gray means they're going to be importing energy from the grids. Okay, so the color does shows what's the self-sufficiency rates for those months of the year. Self-consumption as well. As you can see here, July, we got a high self-consumption rate. Now, you may ask me the questions, why the self-consumption rate is quite high in June, July, because that's the month of winter, right? The reason why it's got a big curves here, or the bars, because system produces less energy, and all those energies self-consumes in June, in the month of June and July. Yeah, so that's why it can be sometimes confusing. That why it's showing it's a self-consumption rate, and this is a self-sufficiency rate. If you would like to increase the self-sufficiency rate, you can just select the different battery storage and see whether that makes any difference. Okay, so these are the real data you can use to simulate the customer's consumption patterns or offer them the battery storage solutions. Okay, as you can see here, everyone, the battery simulation tools, consumption analysis tools is only available to internal employees at the moment. So we are testing the new tools as well, which is also going to help you further analyze your customer systems. Okay, so if you would like to run reports with a few clicks, you can certainly do that. You don't have to use a pen and paper. Just go to the systems, click a few buttons, and it will give you the whole report. Okay, thank you, Dougal.
Thanks, Sam.
Thank you.
Second option, as we talked about, should you wish to click the backup mode, enter in how much backup capacity you wish to retain. It'll show slightly less self-sufficiency because you're keeping some of that energy. Now, future plans. So Sam mentioned this before as well. I'm just going to reiterate it a little. Rod.
Can we go back to meters, please? I'm just going to cover this for everyone here on the meter side. Just a quick update, just while I've got the opportunity. So look, we've pulled in the 240 volt UL meter. So that's a single CT. So it's a 333 millivolt. That is a split core. It is a lot smaller CT, which should be handy. Look, it's not DIN rail, but there is a DIN rail clip available somewhere for that unit. On the next slide, the 480 UL, that one, we're also getting more stock of those. Same again, 333 millivolt, split core, lot smaller CT. Currently, just to update you, the 50 KA3, which we have a lot of stock of currently, the new quick guide does show to change the VT ratio and the password to 0003 instead of resetting it back to 0001. I'm going to contact Sam on that and try and get that guide put back to the original guide that shows just set it to 0001 and do not touch the VT ratio, just the CT ratio. So the 50 KA3 takes a 5 amp secondary. So it's typically it's a value whatever that's divided by on the size of the CT, 20 typically on a 100 amp. So just keep that in mind with the two types. The 5 amp secondary, it's a lot bigger CT, bigger cable. The 480, a lot easier to actually commission. You do the settings in the platform itself instead of doing through the front panel like you do the 50 KA3. Same price, if that makes sense between the two of them. I just thought we'd start pulling the 480 and the 240 unit. So that's just the update I've got on those meters.
Thanks, Rod.
Okay, thank you.
Yeah, that one there. Okay. So with the CT mix, is that how many terminals is there, Rod? Sorry, with the CT connector on the 240-3.
What's the question?
How many terminals is there? Is it clearly shown? The three-phase one has three.
Yeah, correct.
Is that only
I haven't looked at the 240 yet. We don't have any stock. We've just ordered it. It's another
Sam?
month or two out. I ordered it well over a month ago, maybe 2 months ago, finally to get the 240 version.
Is this with a reference voltage?
Yeah, so that's a good question as well. So this is a 240 volt-3 UL. Even though it's got terminals for phase 2 and phase 3, we can only use this one for single phase installation. This one cannot be used for 2-phase or 3-phase installation because we've got a separate meter for 2-phase and 3-phase installation. So it can be confusing. Please specify whenever you are ordering this meter here that you want 240 volt-3 UL because this one cannot be single phase. The other one cannot be used for single phase installation. It has happened sometimes in Australia where installers try to use this one for the 2-phase or 3-phase supply, it wasn't working. Okay, so it's not going to work, unfortunately. So please specify which meter you are using for installation.
The CTs are on the other side, aren't they?
CT terminals are on the left hand side, so on the wires there. Voltage reference terminals are on the right hand side, so you can do the voltage reference there. Really important, the next slide as well, Google, if you can please. As you can see, the major difference between those two smart meter 50K and 480 volt. The 480 volt is not a deep rail mount meter, so if there is no space in the switchboard, you can definitely consider using 480 volt, and that's why a lot of the installers in Australia like to use the 480 volt because it's not a deep rail mount. The other one is a deep rail mount, so if there is no space, then go with that 480 volt because it's much easier to install. Also, as Rod mentioned, that the size of the CD is also much smaller. Okay, so the CDs you're getting for 480, it's much smaller in size. Difference for the CDs as well. The CDs required for the 480 volt has got a 330 millivolt output, whereas the 50K we need the 5 amp output. Okay, so that's the way make a difference. So please use the right CTs for the right meter, because if you are using that 5 amp CTs for the watt per meter, again, it's not going to work, or it's going to give us incorrect readings.
Yeah, and if you're unsure, your Taspac account manager will be able to recommend an appropriate CT for the meter you've chosen. Cool, that's all right. While we're here, and all the way back here, I'm going to go back to this little bit that was about the fastest service. So one of the true advantages of Fronius is that it's field serviceable. You can actually fix a lot of components of the inverter in situ without needing to take the inverter off, send it back to Fronius, wait for a warranty replacement. Now, in order to do this, you need to be a Fronius solutions partner. Is anyone here currently an FSP? Not yet. FSPs, just not paying attention. Yep. Yep, so a couple of you are already FSPs. This gives you the ability to have spare parts in your van. You can use SolarWeb to find out what's gone wrong with the inverter, go to site once, actually swap parts out, and get that inverter up and running really quickly. It'll be the fastest service on the market that your customer has seen. So on the Gen 24 Plus, all the components, and you'll see this afternoon when we start taking the front cover off, are exchangeable. And so you can actually go and swap out those parts rather than having to worry about the whole inverter exchange. So you get component exchange, obviously your automatic notifications, you use SolarWeb, one trip to site. Easy, accessible, and a fast solution gives you a happy customer. And I think that's one of the really critical points, particularly for a lot of manufacturers in New Zealand. It can take a long time for RMA stock to get here. If you're an FSP, you can actually get that system up and running within a matter of hours, and it's going to be a lot cheaper for you in the long run as well. All right, so additionally with the Gen 24 Plus, these are mostly in the US, but if you did want to put in a DC surge protection device, you can retrofit one. There is arc fault detection, which is currently only available in the US, but we're working to get it available elsewhere. Oops. And you can use DC power line comms on it too. All right, so just wrapping up, because I think we're pretty close to lunch. We might have a few minutes for questions. So possible commercial solutions. I mean, we're talking about the three-phase before and whether there was an application for a three-phase Gen 24 here. I think you may, even with some of the net metering that we're talking about, find that there is an application in some commercial premises where it will work, where you may actually want to be putting in multiple batteries, more storage for that customer. We're not really worried about backup at this point. You're worried about having energy storage. Sam showed this before. Just to reiterate, on the HVS, you can do 3 stacks of all the BYD batteries. On the HVM, you can do 3 stacks up to 57.96 kilowatt hours, but on the 22.1 kilowatt hour, you can only do 2. So just be mindful of that. You cannot do 3 stacks of that. Still gets you up to a maximum of 58 kilowatt hours. That's a lot of storage. We are planning to come up with parallel connection of the inverters, where you could theoretically have 3 inverters, each with 150% oversized array attached to them, each of them with their own battery, and comms between the inverters to allow them to all talk to each other. We're thinking probably towards the end of this year, early next year for this solution, and we'll update you all as that happens. So everything that we do at Fronius comes back to this vision board. Many of you have probably seen it before, and we call the vision 24 hours of sun. It's a vision where we have a world that generates, stores and consumes electricity generated by renewable sources. this world has a lot of moving parts to it. There's hydro, there's pumped hydro, there's wind, there's hydrogen, and there's also residential domestic storage. With the Gen 24 product, we've just taken one step closer to making this vision a reality. We now have homes that can be completely powered and have energy self-sufficiency, that can store their own energy for use later, that can rely less on coal-fired power, and can transition to a world that's cleaner and greener for everyone that comes after us. That's why I love working at Fronius. This vision is plastered all over our office, and it makes me smile every time I see it, because it's something it's why I'm in this industry. I'm sure it's why a lot of you guys are in this industry as well. Gen 24, we're just that one step closer. I'm really looking forward to you guys selling and installing it. So we'll have a quick Q&A now. If anyone has any, if not, there's lunch. 12:45 back, Dwayne?
Yeah.
Back at 12:45.
Let's give away one more prize, SolarWeb.
Oh, you want to ask that question again? All right, cool. All right. This one.
For a very snazzy Fronius Polo.
Snazzy Fronius Polo. We'll go by raise of hands, so don't shout them out. What are 3 features of SolarWeb Premium, the paid version? 3 features of SolarWeb Premium. We ran through them just before. Anyone brave enough? Cyril's going to have a crack. Oh, yeah, go on.
Forecasting, sizing in regards to whether you can get battery backup or not.
He's getting some tech support.
He's getting, well, you can give a smaller prize for 2.
All right.
Yep. So Amazon Alexa would have been a good 3rd one. You would have had the detailed analytical reporting that you can drag out of it as a 4th one. So there's a few options in there.
We'll send you a shirt when you buy your first one, Simon. We'll keep that for after lunch.
Okay, cool.
Okay.
All right.
Any questions for Dougal before we break for lunch?
Yes.
Can you AC couple the Gen 24 in an off-grid scenario?
Ooh, you can AC couple it to an existing generation source, so another Fronius inverter or a third-party inverter, but in an off-grid scenario, no, it will want a grid. It needs a grid to work. It's a grid connect inverter. No, it's a grid connect inverter.
You did show the slide with the Gen 24 on the
Promo.
Primo, or is that coming next in Sam's slide this afternoon? I think Sam covers that this afternoon.
No, it was covered this morning.
And I know the answer to this one. So this is quite cool.
Yeah.
So I asked the same question yesterday.
Yeah, we're getting close. Here we go.
So the top snap inverter, that's set to New Zealand country code because it's connected to the grid. Same with the Gen 24. Now, when the grid fails, the meter dies up the top, which is connected to the Gen 24. The snap inverter up the top won't see a grid reference because the Gen 24 is going to go to a changeover circuit for essential loads. There won't be any AC output from the Gen 24 to activate the primer or the snap inverter up the top.
Yeah. Yeah. So this won't act as a grid to fool this into thinking that it's still connected to the grid. So this will effectively shut down, and the Gen 24 would kick in.
So you lose the PV on the primer.
Yep.
Yeah.
And the whole system runs on the Gen.
On the Gen 24.
Cool.
Yep.
The next slide shows the alternative AC. How would that perform in that off-grid scenario? So say that wind turbine's a generator in it. That just run those essential loads.
It will just run the essential loads as well. In this scenario, the same scenario, if you've got a diesel generator as well, or a wind turbine, then it's the AC couple scenario again. So we are showing a wind turbine. We can also show the inverter here as well, but just in case if you've got a wind turbine there. With a diesel generator as well, you've got to be careful there because we can't run those 2 energy sources at the same time. So if the diesel generation is kicking in, we're going to have to switch off this inverter because it may have a bad feed as well. So you've got to be really careful. If you've got a diesel generator there, that's going to kick in the backup situation.
Yeah.
Okay.
So we've got a
two methods to actually turn off the inverter when you start a genset and off grid. Okay. It was two real simple elements.
Yeah.
So as soon as you see an AC source from the Jenny, turn the Fronius off.
But you wouldn't use the G24 and an off grid.
No,
No,
God, no.
Just in the.
You'll find a way.
You'll find a way.
The other thing as well, guys, just important thing, at the moment that we can't link those two inverters physically, so there is no physical linkage between those two inverters. If you would like to see those two inverters output on SolarWeb under the same system, what you can do is, if you've got an existing system with a snap inverter, if you're adding Gen 24 plus, you can add the serial number of the Gen 24 under the same system on SolarWeb. So you don't have to create a separate system. You can add the Gen 24 serial number, and there's another code called V code. V code is also on a label on the side of the inverter. Okay, so that's how you add those. It's just a serial number and V code. You don't have to create two separate systems because there is no physical link as well at the moment. So it might be a question: how do you link them? You're going to have to run the go through the online monitoring setup on each inverter individually. Once you create a system on SolarWeb, you just add the second one system. Okay. Alrighty, thank you guys. Thank you for your attention. Yeah. Right.
Right.
Lunchtime.
So lunch is down the back here, guys. Just come and help yourselves.
Probably just the voice was coming through, right? There we go. I don't hope the voice was coming through.
Yes,
There
right.
was sort of
Yeah,
like
really
crackling or
No, it was good.
beautiful. Might have to look into this one whole setup as well, mate.
Yeah, sure. That's first time I've streamed with this, but
Oh yeah.
I'm not sure how to do that.
Just so everyone knows, the rice and the butter chicken are gluten free, and I think we have one or two vegetarians here who've got separate meals coming for them.
That's great.
Yeah.
This afternoon, when Sam gets one half group around here, that's
Beautiful. To kick things off this afternoon, I just thought I'd show you guys. Sam mentioned the two different backup features that the Gen 24 has. So we've got the PV point, which is literally you're just installing a GPO adjacent to the inverter. The other is your full backup solution. Taspac is going to be supplying separately a pre-made switchboard with all the relays and contactors that you need to enable that feature. So it's all pre-wired straight in. You can option it to have your Fronius smart meter already installed as well. It may be that you've installed a Gen 24 at day one with no batteries and you're retrofitting a battery solution at a later date. You might not need the smart meter. So we're going to option this with and without the smart meter. It's going to come in both surface and flush mount boards. So if you're doing a new build and you want to put a separate flush mounted board in, you can do that. Yeah, so it's really going to have all of the 12 volt signaling that talks between the relays and the inverter, as well as a 63 amp contactor to isolate you from the grid to enable that backup to start producing. The key feature of it is there's a supply in here for your non-essential loads and then a separate one for your backup circuit. But this is designed for the 5 kilowatt model, so it's got a 25 amp circuit breaker for your essential backup circuits. During normal grid tied operations, that's not a limiting factor, which means that you can actually slightly overload your backup circuits and it won't continually trip that breaker when the grid's in place as well. So it'll actually bypass the emergency supply until it needs it. It just gives you the ability to put a few heavier things on there and then just enable your customer to realize power turns off for about 60 seconds, the lights come back on, they know that they're now running in backup power supply. And so they know that they can't just go and turn on every single load in their house or whatever you've configured on that backup circuit. So we're going to be, I'm still getting the final costing on these, but we're going to be getting them manufactured and certified, and they'll be there for you guys to purchase. I'll leave it up the front, and when we do the practical stuff, you guys can bury your head in it and figure out a bit more about how it works. But there's also documentation on our support site for the way that the backup changeover happens. So there's a Fronius document for that. And I'll hand things back over to Sam.
Fantastic. Thank you, James. That's it.
Yeah, I'll put them on if you want.
Lovely. It's all set. Okay. All right, guys. Thank you again for this is the second session. We're going to be covering the technical parts here. So some of you who are doing the installation, this is going to be a very exciting sessions as well for you guys, because we're going to be learning how to install the Gen 24 Plus inverters and how to commission the Gen 24 Plus inverters as well. And I'll be showing you guys how to understand the implementations of the backup function. So what contactors requires, what relays requires. James said that there is a backup box available for you guys, so you don't have to really look for the AC contactors, and the relay is already inbuilt into the box, including the smart meter as well. But I'll just give you cover how to connect those contactors and relays to the inverter's pins. Okay. Before we do that, give you a quick overview on the installations. We're going to cover the best installation practices because sometimes if you don't install this inverter properly, it may cause some issues. So we're going to be looking at some installation practices on Gen 24 Plus. So when we wanted to sort of design this inverter, we want to make sure that this can be installed within a few minutes. Okay, so when you open the box on the Gen 24 Plus inverter, what we'll do is you will see the mounting bracket first. So it's placed right on the top, and then you got the inverter part, and then you got the front covers. Okay, so it's been designed or it's been packaged in such a way that it's gonna make it much easier for you to install. You don't have to take the whole inverters out of the box, disconnect it from the mounting bracket, and then install the mounting bracket. The mounting bracket is on the top. You just get one piece out, installed first, inverters out, hinge the inverters onto the bracket, and then put the covers onto the inverters. Okay, so that's much easier as well. We wanted to reduce the time that we take on the installations, and it's much easier. But this is how the mounting bracket looks like, everyone. As soon as you open the box, you will see this is a mounting bracket or wall bracket. And just always make sure, please, that this arrow is pointing upwards, because if it's pointing downwards, you may not be able to hinge the inverters on the bracket. Okay, so that's the key here. Also, please use the designated here, those for the screws. Otherwise, if it's not hooked on properly, or if it's not connected properly on the bracket, we may have some issues. Now, on the snap inverters as well, we got a very similar mounting bracket as well, with some of those holes also provided on the bracket. See how these small holes? Please do not put the screws on those holes, because they are not for putting the screws on. This is the designated provision. We got a provision here for putting the screws on, so please always use those ones to mount the bracket onto the wall. Okay, because we have seen sometimes some installers in Australia, they use these holes and put the screws on that. It wasn't. And then a few days later, we found a moisture ingress, we found a water ingress as well inside the inverter. This is with a snap inverter, but it can create a bit of a confusion as well. So always use those designated area. Okay, when you mount the inverters, the front compartment, which is the inverter compartment, onto the bracket, as you can see, there is again, when you are hinging it, make sure it's connected properly here. You will hear the noise as soon as you plug that one onto the bracket. You will hear the clicking noise. Okay, I'll show you in a few minutes how to mount that one onto the bracket, but please always make sure that it's clicked on properly, because if it's not clicked on properly here, again, it's going to cause some issues, okay, in the future. Okay, so let's have a look at the front compartment of the inverter. There is an inbuilt DC isolator, so it's right in the front of the inverter. As soon as you remove this front plastic cover here, it will give you an access to the DC terminals and AC terminals. As you can see here, everyone, that we use this 180 degrees lock-in screws. Okay, so you don't really need a special toolkit to remove the front cover. You just use a T20 screwdrivers, turn those screws 180 degrees anti-clockwise to unlock it, 180 degrees clockwise to lock it. Okay, so you don't really need special tools to remove this front cover. So behind this cover, we do have all the connection compartments. When you are connecting your DC cables and also the AC cables, as you can see, there is a special plug used now. These are not the screw terminals as the ones used in the snap inverters. Snap inverters, we got a screw terminal, so you strip the cable, insert it, and connect your cables to that. But these are the special terminal plugs that we made for the Gen 24 Plus inverters. It's called spring-in terminals. So all you have to do is disconnect them from the inverter. So you press this clip here on the bottom and just disconnect them from the inverter. Lift one of those pins up and insert your cable, okay, and push this one back down. It will lock the cable. Okay, so much easier to install as well. The reason I think we've gone with this sort of spring-in terminals, because with the snap inverters, what we found is that sometimes the installers, they don't screw down those wires properly, and it creates an arc and ended up damaging the DC terminal blocks. So those sort of issues can be avoided. Hopefully we won't have any of those issues with these sort of special screw-in terminals. Much easier. I'll show you guys as well, and you can see that how to connect those cables to those screw terminals, okay, or spring-in terminals. Sorry.
Should we be ferruling or not ferruling the DC?
I mean, installers, it's your preference. If you wanted to ferrule it, yeah, it's always good. But if you don't want to, that's also fine as well. It locks us in. But as a good practice, I think if you would like to do that, then it can certainly be done too. On the AC side as well, we got line 1, line 2, line 3, the same spring-in terminals used too. And this is how it looks like. Sorry about the picture quality. It may not be great, but this is how it looks like. These plugs, they look a bit different because this is from the very first inverter, but the whole concept is the same. So the DC connection area is on the left-hand side of the connection compartments. These are all the comms connections here. This is just like a separation cover we got in the middle. And this is the AC area is mainly for the AC connections, okay? As I mentioned in my previous presentations, that there are separate AC terminals for the PV point. Okay, so these are the normal AC terminals or plugs, and this is one here is for the PV point. Okay, so it's got the line 1, earth and neutral connections there for the PV point. Okay, so it's already inbuilt here. There are a few knockouts as well. It's up to you which one you wanted to use it, but there's also a provision for the back entry now. So if you would like to run the cable from the back of the inverters, there is an additional knockout, and you can run your cable from the back of the inverter, okay? Whereas with the snap inverters, there was no options. It compromises the IP rating of the inverter, whereas this one, it's already been provided, okay? So make it the installation nice and neat. So it's your preference. However, there are some other terminals here as well for the DC connection. You can also use this, but installers, they like to use one of those knockouts for the DC, for running the DC cables, okay? And these are the connector plugs. As you can see, we have got comms as well, the pins. These are the input I/O pins. This is where you will be connecting your smart meter as well. So quite a few of those interface plugs provided inside the connection compartment, okay? This is where also you can find the serial number here as well, just the case. There's one inside, but there's one on the side of the inverter too. Okay, so this question is also asked frequently in the tech support department as well. So installers, they would like to know what's the spacing required, because inverters, they do dissipate the hot air from the side and from the bottom and the top as well. So you're going to have to make sure that there is enough spacing if you are installing 2 inverters side by side. Okay, so please always make sure that there is a spacing. Otherwise, the heat coming out of the first inverter can get into the second and cause the derating. Okay, so this inverter will start derating its power if the heat. So these specifications are given in the installation manual. So please refer to the installation manual, and you can look at that. The other important question is asked about how to connect those multiple strings, guys. Okay, so very useful slide here. Very important slides. I'm going to cover all the 4 scenarios here and show you guys how to connect those DC strings to the inverter's DC terminals. Okay, so let's have a look at this one here, this scenario where you are using just the 1 string. So if you've got a 1 strings of panels and you wanted to connect this one to the SIMO Gen 24 Plus. We are looking at the SIMO Gen 24 Plus inverter here because the maximum current the first tracker can handle is 25 amps. Okay, so as you can see here, everyone, this is a very easy one. You can just connect the DC positive to PV1 and DC negative to PV negatives. Please note the PV negative is here, not here. So if you're going to connect it here, it may not work. So PV negative starts from the right to the left. Okay, so that's PV 1 string. Very easy. You may have a scenario with this sort of setup where you are combining the strings on the roof. Okay, so if you've got 2 strings on the roof and you are combining those 2 strings in a combiner box on the roof. Okay, so what you can do is you can certainly do this one as well. You just have to connect this DC positive to PV1, PV2, because this tracker can handle 25 amps. So if you're combining the strings, if your current is less than 25 amps, you can certainly do that too. Okay, but this is a very interesting one here. You are combining the strings, but your current is greater than 25 amps. Okay, so this is your currents, which is going to be greater than 25 amps. As you know, that the sign was Gen 24 Plus. MPPT1 can only handle 25 amps, so you're going to have to find a way to distribute that current into the 2 trackers. Okay, so this is very, very important, guys, because if you are not doing this one here, and if your current is greater than 25 amps, then it's going to cause some issues to these terminals. Okay, it may potentially or might potentially burn the terminal as well. So always check how much current you're getting whenever you are combining the strings on the roof. But I believe that not many installers will be combining the strings on the roof with the Simo Gen 24 Plus. This is why we've given a really sort of high current rating here. So this is why the tracker 1 can handle 25 amps. So I believe you won't have this scenario out in the field. And this is a very easy one as well. So this is probably, I think you guys will be doing that quite a lot, where you got 2 strings. Each one's connected to the tracker 1, the second one is connected to tracker 2. So this is again a very easy sort of scenario for you too, right? So you're not combining the strings there. Okay, right.
The top right-hand diagram, just so you know, guys know, all the snap inverters we can, jumper over to MPPT2, and I see it's a bit small on the right.
Yeah, this one.
Turn MPPT2 on, leave
MPPT2
MPPT2
off.
Yeah, if you're going to jumper them over for current, just leave MPPT1 on only.
Yeah, so in the snap inverters as well that we can. Yeah, so this one you have to leave the 2 off. Thank you, Ron. In the snap inverters as well, you can jumper it in this fashion, but unfortunately, you can't do this with the Gen 24 Plus. You're going to have to sort of find a way to distribute the current, which I believe hopefully you won't come across with this situation or scenario. It's going to be very straightforward. But we thought we'd cover this slide because sometimes it can create a bit of a confusion there. This one's also given in the manual too. Yeah.
The spring terminals, I think, are 16 mil maximum size.
16, yeah.
And then if we've got to double up, would you have to parallel externally of that spring connector, or could you put 2 sets of cables?
You have to do like an externally, unfortunately, yeah, external joint. Yeah, yeah, yeah. Thank you, Ron. Okay. All right, so I think what I'll do is with the pilot commissioning, so that was the installation part, everyone. Now, as you know, there is no display screen in the front of the inverter. So a lot of the times it is going to be I don't know, some customers, they like having a screen on the inverter. Some customers, they want a screen on the inverter because they would like to sort of navigate through the different menus on the screen. But this one doesn't have a screen, which is not going to create a big issues, because if we put the screens on that one, guys, we're going to have to like show so many values if you got a battery connected. So if you got like battery connected, you have to show them the charging level, discharging level, charging power, discharging power. So it's also going to increase the cost of making the inverters as well. Everyone's got, sorry, right here.
I'll just back up to where we were before. Simon's actually come up with a good idea. Just put Y connectors externally in the box and then run 2 separate cables up into the spring.
Okay, fantastic.
That's one way around it.
Great idea. Yeah.
Sure.
Yeah, I'm just hoping like because it's, even if you get a 390 watt panels, the IMP current is going to be about 11 amps. So even if you are combining the strings, you probably hopefully won't have to do this one here. You don't have to run the jumper. You probably can do this one here if it's less than 25 amps. So
do it externally with Y connectors and
yeah, Y connectors. Is it like it's got an MC4 connections on the side as well? So you plug it in. Yeah, beautiful. Thank you, Ron. So yeah, with the screen as well, I'm sure that some customers, they probably just kind of feel uncomfortable about not having a screen on the inverter. But as I said, if you're connecting the battery, you're going to have to show them so many values on the screen as well. So this is the reasons why I remove the screen, and everyone's got a smartphone anyway these days. So as soon as you connect this inverter to the internet connections, you can then analyze all the system values on the smartphone. Okay. There is a pilot, there is a data manager card inside the Gen 24 Plus inverters, snap inverters. It's called data manager card. But in the Gen 24 Plus, it's called pilot. Okay, so it's not called data manager card, it's called pilot. Because it's the brain of the inverter, it is the driver, it drives the inverter's circuits. That's why it's called pilot. So the commissioning part is much easier. Once you connected cable to the inverter's terminals or spring terminals, the commissioning is the easiest part. Okay. In terms of the connecting cables as well, everyone, please make sure that you measure the voltages before putting the inverters onto the bracket. It's always a good practice. You're going to have to measure the voltages, because if you connect and switch on the DC, you might hear a big bang sometimes as well if there is a earth fault happening. So if there is a genuine DC earth fault happening, so do the mega test as well. Double check, triple check if you can, especially with the 3-phase inverter as well. Measure the phase-to-phase voltages, phase-to-neutral voltages. Make sure that they are within the limit. Otherwise, it may create some damage to the inverter. Okay. Had a few cases where installers connected a line cable to the neutral connections or neutral terminals on the snap inverter. So it ended up becoming 400 volts across the line and neutral, and then it damaged one of the printed circuit board of the inverter. So it kind of hinge. So those are the things really good. If you can just have that sort of practice, it's going to be really valuable and useful as well. Once you've done that, there is a front cover here. As you can see, there is no screen. So here we got LEDs, 2 LEDs, one for the inverter. So the one on the left-hand side gives us the inverter states. The one on the right-hand side is going to give us the monitoring, so whether the monitoring working or not. So as soon as you turn the DC on, AC on, this is how the LED status is going to be. Just wait for a couple of minutes before they go solid green and solid red. This one is solid red, means it is not connected to the customer's internet. So this is how it looks like. If you want to activate the Wi-Fi access point, you just have to press once in the run, and it will activate the Wi-Fi access point. So we have activated the Wi-Fi access point now. Okay. Right. So once you've done that, deactivating the Wi-Fi access point, you can either use the Fronius Solar Start app. Have you been using the Fronius Solar Start app? How many of you use the Fronius app for commissioning? You all using the Fronius Solar Start app? Is it the new one? Beautiful. So as soon as you open that app, it will ask you for which inverter you are commissioning. You are commissioning the Gen 24, so you select Gen 24. With the Gen 24, there is always this first step about on uploading or downloading the firmware on the inverter. Okay, so download the latest file first and upload the software of the inverter, because the inverter may have got a really old software. Okay, so it's always a good practice to upload the firmware of the inverter as soon as you commission it. So this is how its uploading process works. You download it from our website and do the upload. So I'm not going to go through this one in detail, because I wanted to show you guys a few things here, the connection compartment as well. But any questions about the commissioning as well, please let me know. How many of you guys been using the IP address for commissioning? How many of you guys use IP address? There you go. Perfect. Good stuff. So IP address is also another way of commissioning this inverter or setting up the Fronius online monitoring. You don't have to use the app. You can also use the IP address, which is always the same for all the inverters, and we kept the IP address same for Primo Gen 24 Plus inverter as well. Okay, so this is the IP address, everyone. If you don't know, please make a note. You can always bookmark it. As soon as you connect your smart device to the Fronius access point, you can always type in this IP address in a web browser, and it will take you to the same steps. Okay, I'll show you what other steps look like and how to go through the steps as well in a minute. But just want to mention the IP address is the same, everyone. Okay. Alrighty, so I've shown you how to activate the Wi-Fi access point, go through the whole process. So when you type in the IP address, it will give us 3 options, okay? So it's only a 3-step process. It's only a 3-step commissioning process. First one is the network settings. So this is where you enter the customer's Wi-Fi password and connect the inverter to the customer's internet. This one here, as the name suggests, is saying products. So this is where we activate all the products. Okay, so this is where you can activate the smart meter. This is where you can activate the battery as well. So this is the product configurations sections. And once you connect it to this one, to the customer's internet, activated the products, you can then register the system on under your SolarWeb account. Okay, so it's only a 3-step process, everyone. As soon as you do that, you will be able to see the system added under your account. Okay, so I'm going to demonstrate this one here right now, so you can also get a good understanding how to connect this one to an internet connections. Okay, so those steps are given. I'll send you guys the PDF copy as well, so you can always refer to this one. We already covered the smart meter as well. The smart meter is going to be compatible with the Gen 24 Plus. We look at the different types of single-phase smart meter. We also look at the different type of 3-phase smart meters too. So I wouldn't go into detail, but there is a slide here, a couple of slides, very, very important whenever you are installing the smart meter, right? So when you install the smart meter, you have to configure the smart meter. So when you are configuring or activating the smart meter, there are 2 options on the page. One is called feed-in point, and the other one is consumption path. You may have seen this one as well. Does anyone here know what's the difference between the feed-in point and consumption path? Yeah. Yeah. Close there. So. Yeah. So here, just quickly cover that, because there's always a questions around it. There's always a bit of a confusions as well. What's the difference between feed-in point and consumption path of the meter? Okay. So feed-in point is the most common locations of the meter in the switchboard. Okay. So what is feed-in point? Feed-in point is when you have a meter connected in series with the main switch of the property. So you got utility meter. You will also have a main switch of the property here. You then install the Fronius smart meter. And on the other side of the smart meter, you've got all the breakers here, okay, for the electrical loads. But also on the load side, you install the solar supply switch. Okay, so this is where your solar supply AC switch. Again, this is your AC switch. So your solar supply switch is on the load side of the meter. That's when we call feed-in point. Okay, whereas with the consumption path, as you can see, everyone, the solar supply switch is actually on the grid side of the meter. Okay, so that's when we call consumption path. But feed-in point is the most common locations. I believe you guys all installed the meter straight after the main switch of the property. It's in line, it's in series, right? But you got to be sometimes careful, because if your solar supply switch is on this side, and if you select feed-in point here, it's going to give us incorrect readings. Okay, so always just double check which side of this meter the solar supply switch is, because our meter does the calculation slightly differently. So as you can see with the consumption path, it doesn't know the generation; it only knows the consumptions at the side. Whereas with the feed-in point, it does know what's the inverter power as well as the generation as well. So it does the calculation slightly differently. Okay, so it's always good to just double check the physical location of the meter and then select this feed-in point or consumption path. Sometimes it can be really hard in the switchboard as well, because switchboard you got so many breakers, so many wires. So just have a visual inspections inside the switchboard if it's not easy to see. But if you are getting any incorrect readings, it's always a good practice to just double check. Okay. All right. There's a few slides on the backup as well, so we'll cover that a bit later on. But what I wanted to show you guys is how to remove this front cover as well. So I think we're looking for T20. Yeah, there you go. I had it there. Yeah, you have to answer questions, isn't it? Yeah, there's another one. Thank you. Yeah.
Oh, you've done a price.
Yeah. Yeah. Yeah, I thought so too as well. There was another one. No, so that he's gave me to the. It was a prize. It was a prize one. There was another one here, but that's fine. Yeah.
We gave away one as a prize this morning.
Awesome,
We
yeah.
had 4 in total, 2 yesterday, 2
Yeah,
today.
so probably is it? Yeah. I think so. I think it was probably put in the box. Legend. Thank you. Yeah, we'll give it to him again. So this is how it looks like, everyone here. I'm going to remove the front cover, but before I do that, I think I'll show you guys the commissioning part, because the Wi-Fi access point is on now. So I just wanted to show you how to commission that inverter using the IP address. So first thing first, I guess what you're gonna have to do is, once the Wi-Fi access point is activated, you go to the Wi-Fi setting of your device, and you should be able to see those Fronius Wi-Fi access point coming up. Okay, so it's the same thing. If you have an iPad as well, you should still be able to see that. We can see the inverters there with the serial number. So I'm gonna connect to this access point now.
Since Sam's already connected to this inverter yesterday, it connected to it.
Yeah.
The password is the same as the snap inverters: 1, 2, 3, 4,
5, 6, 7, 8. There you go. So it's connected now, everyone, but it's saying no internet. So please don't get confused. It's saying no internet because there is no internet connections. We are connecting this device to the inverter's local access point. So we are not going to browse the internet. There is no internet on that network. It's just a straight point-to-point connections. Okay, so that's why it's saying, sometimes installers saying, oh, how come there is no internet on the Wi-Fi access point? So they can create a bit of a confusion, but we are communicating straight to the Wi-Fi access point there. So what I'm going to do here, browser, I should have that IP address saved already. So type it in, press enter, and it should give us those 3 options that we looked at before. There we go. It's a bit off for some reason. Yep. Okay. So these are the options. What we're going to have to do here, everyone, just let's connect this one to my hotspot. So network part, you just go here. Yeah, but there's free Wi-Fi, and you have to kind of give your email address. So it may not work. So I can probably, I'll go with my hotspot here, everyone. So with something here. But before we, yeah, yeah, can please feel free. So first thing first, everyone, as soon as you click on it, you're going to have to create the password. Okay, so remember there was a password as well with the data manager card. It was called admin password. So now this is called customer password. So I'm going to create a password here, customer 123. customer 123. So please always make a note as well, or maybe have a system. I don't know how you create the password for those steps, but it's always important to make a note of those password and save it somewhere. So I'm just gonna create that password now. Okay, so what it has done is my computer is still sort of got a Australian setting there, so it's grabbing those values here, the date and time. So you can always change it here too. I'm going to change it to Auckland. Go next. PV system name, as you can see, I haven't entered the PV system name. That's why it's in red. So test 1, 2, 3. Go to next here. Terms and conditions again. You just have to read through it, or you can accept it. And this is a very important step, everyone. Okay, very, very important step here. Three options. Ethernet means via LAN. So you are running the LAN cable from the customer's modem. Very easy to understand. Wi-Fi is your Wi-Fi connection to the customer's Wi-Fi modem or router. Again, easy to understand. So this one here can be really confusing. Sometimes installers, they think that this is a Wi-Fi options or Wi-Fi connectivity to the customer's modem, but that's not. This one here, does anyone know what's this one used for? Yeah. Just close. Yeah. So this one here.
That's what you connected to just now, right?
Correct. Yes. So maybe if you can just give this gentleman the thing, he's answered the correct. Yeah, I'll go for.
What was the answer?
Yeah. Oh, good catch. This one here, guys, as it says, access point. So let's just say there is no internet connections, right? And if you wanted to have this access point on all the time, okay. So if you wanted to keep that access point on all the times, you go with this option here. Okay. There was a question yesterday that if how do the customers can see their system values if there is no internet connection? So you can always activate that, have that on all the times, and customers then connect their smart devices to the access point and use this IP address. There's a limitation there though, because it doesn't save all the archive values. It's only got just the overviews of how much energy is produced by the systems, what's the energy flow to the grid and from the grid, but it doesn't save all the archive values. Okay, so customers can definitely use that option as well, or you can set up for customers. What I'm going to do here, everyone, that Wi-Fi, so I've got it here. You can also check the signal strength here. It looks a bit different. It doesn't have the bar, but as you can see that this one's got the strong signal here. So what I'm going to do is type in the password and I'm going to go connect. You guys always do the Wi-Fi connections to the customer's modem or run the LAN cable from the Wi-Fi connections? Try to LAN. That's always good practice. I mean, if you can do that, that's always recommended because a Wi-Fi connection is not the most reliable. If it's going to drop out, all those issues. So if you can, then that's always a good practice. Connections failed, invalid key. It's definitely the right one. Unless this is a bit of a... Password is right, but I think unless there's a bit of a issue with my securities on that one, on that work phone. Might use your James if possible. Thank you. What's the common issues like you guys always face at this one here? Is there anything that you would like to sort of cover?
Like how
Me?
strong needs to be the signal, like how many decibels or something they used to use.
If you have a one or even one bar as well, it will connect, but depending on the days as well, if the signal is going to start dropping, it's going to disconnect. So maybe 2 bars is probably the more for more stable connections. 2 bars is recommended. Probably have to refresh it. Refresh. So this is the refresh options as well. If you just want to see the other network, just quickly refresh it.
One was to get the password, not the other customer password.
Good questions. So if you've forgotten the customer password or the other password, you can contact our technical support department and they will send you the temporary password. You can always contact us beforehand as well, before going to the site, so that you already got their password with you. Okay, so it's dependent on the date as well, what day you're going to the site. Okay.
So whatever passwords we select are visible for you guys.
No, we can't see the password. We can create a temporary password,
right,
which you can copy and paste it as well, and we can't see the password. No.
Is the time limitation on the temporary password?
24 hours. So you have to use it in 24 hours. Yeah.
I'm not the only one who has these connection issues with Fronius. There's always something that's not quite.
Is that the one? Is that the right one?
Yeah,
Last one?
should be.
Yeah, there you go. Yeah, I think again, so having these issues is always good because you know, like how to navigate through those sort of problems. I think what happened with my phone, maybe a bit of a security there, it didn't allow to connect any third-party device. Yesterday we used the iPad as well. It wasn't going through it. We used the laptop and it worked fine. So always please make sure that you've got a couple of devices there if possible, and also a couple of browser as well, because it can be an issue with the browser too. So have a Safari or Google Chrome or Firefox, couple of browser, just in case if one doesn't work, you can always try the other browser. Okay, so this one is connected here to the James hotspot. As you can see, it's changed the color too. So I'm going to go next. And it has got a green tick there. Okay, so when you see the green tick, means it's connected to the customer's network. I'm going to go to the product sections, and again, there's one more password that you have to create, which is a technician password. Okay, as the name suggests, only technicians can activate the smart meter, batteries, on pilot, so that's why it's a technician password. In the Snap inverter, used to be called service password. Okay, so now this is called technician password, so we're going to create. You can always check your password as well by just unticking that I symbol here, and it will show the password. So I'm going to go save. So when you go to that sections again, it's just going to ask you quickly the date and time, and also what it's going to ask us is the country setup. Okay, so as you can see the country setup, there is no screen, so you're going to have to do the country setup here. New Zealand, and also we got New Zealand here. Australia time zone, again, you can change that to Auckland. Yesterday there was a questions asked to me as well, James, that there are 2 New Zealand setups now. One is a normal and the one, so I'm not sure whether there is a power factor settings here. Do you guys have to do the watt settings? Not yet.
It's sad that that's been entered in.
So I'm not really sure. There was I think questions there that we got 2 New Zealand setups. One is the normal one. Now, yeah, in AU as well, we got normal setup, but then we also got a setup for different utilities. So different grid operators, they've got their own requirements with the power factor settings, watt settings. So
Victor started to push it.
Push it the
On the larger stuff. tell no export. But mind you, all the bigger ones, people do want the export, don't they?
Yeah.
Yeah.
Mm.
And then can you set these things up for reactive power? Can they give off reactive power?
It does.
In
It
case
does.
You've got power factor issues in a building?
Yeah, so then you're going to lose the real power,
Yeah.
but you can
Then
definitely
you can
combat it. Yeah.
Okay.
But if you are looking for some sort of a power factor corrections, then unfortunately it cannot be done. It's hasn't got that power factor corrections mechanisms. It's just
You can produce reactive power.
correct. So you can change the power factor to lagging or leading,
Yeah.
and you can manually set that.
Yeah.
And it will change it. But some of the utilities in Australia, they change the power factor based on the grid voltage.
Right.
Okay, so grid voltage, as soon as it goes about 255, the power factor on the inverter is going to be 0.9 or 0.8 lagging. What happens with the lagging power factor? Your real power drops, and it helps with the voltage rise issue on the grid lines. So in Australia, there's a high penetrations of the PV systems, many PV systems connected to the grid lines. So we have these issues of voltage rise, and the inverter is going to disconnect as soon as the voltage is going to be about 255. But with these sort of methods, inverter is going to continue to produce, but with the less power. So the customer is not going to lose 100% of the energy. Okay, so those been, I think, put in place by many utilities in Australia. There's some SA government. SA government is they've got a like very advanced setting as well. So they would like the ability to disconnect and connect the inverter remotely as well. So they can actually send the signal to all the inverters connected to their network, and they can remotely connect and disconnect. So those are the requirements coming. I think it's probably be adapted here as well at some stage, but at the moment it's not here. So which is, yeah. So at the moment it's not there, which is good.
No.
What's solar?
So we got to the next here, guys. Here you can set the country setup because there is no screen. So this is where you can do the country setup. Device configurations here. This is also a very important step here, everyone. Still connected. Yep. So here, what you're going to have to do is you can always add the devices. Okay, you may think that there's going to be a smart meter here shown, but it's not displayed smart meter. You're going to have to manually add the smart meter and also the PV power as well. So as soon as you click on this add component, as you can see at the moment, we can add 3 components, PV generator. So let's add PV generator. Always a good practice to add what's the DC power you connected to each tracker. Again, it's in watts, so I'm going to just type in 2500. Whatever the powers that you connected to that tracker, just enter those values. Add. I'm going to add the smart meter. Again, it's called the power meter, so please do not get confused. It's called power meter instead of smart meter, but it's the same thing. So when you click on power meter, the locations is also not called feed-in point here. It's called grid connection point, but it's the same as feed-in point. And then consumption path is called load branch here. So again, different names used, but it's the same as the snap inverters. Okay, so please do not get confused. We just want to come up with the terms that's also accepted around the world. That's why it's called grid connection point and load branch. Okay, so I'm going to add this meter here, everyone. It's not going to find the meter. Let's. I think it's skip past it. So, sorry, I'm just on your. As you can see here, everyone, that it's got a red dot here. That means it hasn't found the meter. But if it's found the meter, it will be a green dot here. So that's how you know whether it's found the meter or not. And also, it will start showing the value here. It will be negative or positive, depending on whether you're consuming or exporting the energy to the grid. Okay, so that's all the settings there. Battery, you can also add the battery here as well. So if you would like to add the battery, BYD battery, you select what batteries you're using, auto, If there is an existing system here, everyone, you can also enable that. Or if there is you want to charge the battery from the grid, this option is always useful as well, just to keep the battery at the minimum SOC level, okay? So it's always to draw a little bit of energy from the grid, especially on a cloudy days. If you're getting a cloudy days for 2 or 3, 4 continuous days, then it will grab a bit of energy and keep the battery SOC level at 5%. Okay, so that's also important. So this is all where you can add all the components or the batteries. Go to the next one. Okay. So functions and I/O. So I/O and input. So these are the pins that you see on the orange connector plugs. So you know how there's a big orange connector plugs? It's the exact same pins. But here what we can activate here, we can activate the backup power here. So you can always activate the backup power functions. Please make sure that you've got the right pin selected here. I'll give you a quick overview on how to connect those pins once we look at that inverter. But those are the pins used for the backup functions, okay? And the question was, can we reserve the capacity for backup functions? So this is where you can reserve the capacity, 30%, all the way up to 95% as well, okay? So this is where you can reserve the battery's capacity for the backup functions. Again, the load management, if you are also activating or switching on a specific load, based on the surplus energy, then also you can activate that too. So this is, I'm going to activate that now. Go next.
And can you do time of use charging?
At the moment, there is no options available, but we are working on a software. So we have it. You just have to update the software, and you can set the different time range and SOC level for that. So time of use is still being implemented at the moment. Export limitations there. So export limitations, again, as you know, if there's an export limit, 0 export system or limited export system, then what you can do is just activate that, whatever the limit there is. It's in a percentage here, everyone. You can change it to watt. It will change the color. And total DC power here, very important figure or values if you've got an existing system there. If it's a third-party system already at the site, you're going to have to add that existing power as well. So if it's a 3 kilowatt existing inverter and you are installing a 5 kilowatt Gen 24 Plus, you're going to have to enter 8,000 there. Okay, so that's very important too. 3,000 is the laptop from the Wi-Fi access point. Connect back to the internet because this step will ask you to log in. Okay, so that's why you need the internet connections. So you can't do this step if it is not connected to the internet. Okay, so always make sure this one's got a tick. Disconnect your laptop or smart device from Wi-Fi and then start this step. But if you don't want to do all those steps here, you can also do those steps on the interface page of the inverter. Okay, so you can always skip the whole visit here. As you can see, there's an option. Okay, if you don't want to do all those settings, if you want to do it on the main page, it can also be done too. So I'm going to skip the visit here, and I'll show you how the interface page looks like. Okay, so this is how it looks like. As you can see, it's got the same energy flow diagrams. If you've got a Fronius smart meter connected, if you don't have a Fronius smart meter connected, it's going to look like this one here. General information here, but also you've got to advance. So when you go to the advanced, it's going to show you like the DC voltage, AC voltage values as well. So it does show this advanced. It does have the sections where you can access all those voltage values. Power meter, if it's active, it will say active here. Okay, so I think I've gone to the service messages there. But these are the tabs you can access. There's the 3 lines here. Just click on it, and this is where you can also set your smart meter. You can also activate the other components too. I wouldn't go through all of them, everyone. Very important, the section here as well, everyone. This is a system, the tab here. When you go to the system tab, sometimes we may ask for what's the software versions on the Gen 24 Plus inverters. You can always update the software on the Gen 24 Plus inverters using this option, update. You can drag the update file in this section and we'll do the update, okay? So you can download this file from our website. There is a latest file, software file on our website, and you just download it and you can drag that file here. Or once you save that file into your smart device, you can also browse the file from your smart device, okay? So that's options you will probably be using quite a lot. If you have to do the factory reset, you can also go to the factory reset options and reset all the settings back to the factory settings, okay? Other options that we added, which is also going to help us with the troubleshooting, is this remote access, okay? So when you enable this activate remote access, we can remotely access this page, okay, for 72 hours. So if you are struggling with any setup or having any complex issues, you're going to have to activate that remote access here, and we can remotely access it, or our R&D department can remotely access this page and help you with the troubleshooting, okay? But unfortunately, we're going to have to activate this one here first, okay? And you can only access this page if you are connected to the Wi-Fi access point of the inverter, okay? All right, let's have a look at the grid settings here, because if you skip the whole visit and if you would like to enter the country setup on the inverter, how do you do it? Like, because, you know, in that visit, we did it under the product sections, right? But if you skip the whole visit, where would you actually set up the country on the inverter? So in that case, you're going to have to go through this tab here, safety and grid regulations, and you've got a country setup. See how it's got the lock symbol here? That means it requires an access code. Does anyone probably know the access code for setting up the grid parameters on the Snap inverters? I think everyone knows about it. It's not a very secret. Like if you want to change the something, yeah, probably it's the same code as well, 5-digit code. So you enter that and you unlock it. So it's been unlocked, and you just have to go back again to this setting here, and this is where you can again select the country setup. You can also change some of the grid support functions too. But please do not give this access code to your customer, because if they change one of those values, it's going to be difficult to find what's causing the issues. You know, even if they change one of those values, then inverter's not going to perform well, okay? Or it may disconnect. So I hope you are not giving this access code to your customers, and also the technician password as well. Australia installers, they don't give a technician password or service password to customers. But I'm not sure, do you guys give out the password to your customers at all with the service password and technician? No, okay, yeah, because otherwise they change those values. Admin password is important, so you can definitely give the admin password to your customers. So if they change the Wi-Fi modem, they can also change the Wi-Fi setting, okay? So those are the tabs here, everyone. This is an overview page, very straightforward. As you can see, it's got some additional tabs and features, and it gives you more visibility as well. So this is the whole page here. Okay, any questions, everyone, with the interface page?
Could you show them the PV PowerPoint part and the battery?
That's a good point. Thank you. Right, so with the PV point part, we go to the. Sorry, I've gone really quick here, but this is where you can activate the PV point. Now, again, you know, once we connected the wires to the inverter, there's always a configuration parts. And it's not going to work as soon as you connected the cables. Gone are the days, guys, where you connect the cables and it worked. After connecting the cables, you're going to have to configure those settings. You know, so there's always this few steps required. So once you build the GPO for the PV point, you're going to have to activate that function, because otherwise the inverter won't know when it needs to activate the PV point, right? So where do you activate the PV point? So you go to here, device configurations, functions and IOs. So at the moment we have the backup power activated. So you just have to activate the PV point here, and it will also activate the PV power. You can also reserve the capacity for the PV point too. But you can't have the PV point and the backup powers working simultaneously. Yeah, you can have a PV point or backup power. Okay, so this is why that setting is there. Please activate it, otherwise it's not going to work.
So when you activated PV point, that reserve capacity percentage is irrelevant.
It's battery, yeah. So that's why if you wanted to reserve that capacities, but again with the battery, you wouldn't do the PV point. You would always do the backup functions, I think. Yeah.
That's a good point. Yeah, there's no battery there.
Mhm.
Confusing. SOC.
But you can have that.
But some, yes. Yeah, just in case if some installers they do.
You have to put the anti-islanding switch in, don't you? So if you're going to go to that extent.
Well, not if you use the PV point backup, because it's just a single GPO.
It's a single GPO.
That's the advantage. You had a battery, but for some reason didn't want to put the backup.
So you could have the battery in there and not have all that anti-islanding relays.
Correct. Just have one GPO.
One GPO, yeah.
How does it disconnect?
With the PV
It's a separate AC output, that one. Okay.
Sorry, when like you are in battery backup and you run the battery completely flat because you have it in reserve and you use it all, will the system come back to life in the morning if there's still no grid? Yeah. Will it start charging your battery? Because some systems will just not.
So in the backup situation, it will still charge the battery for sure. Yeah.
So you might get to a point where your battery is at zero, everything in the house goes off, but in the morning, when the sun comes up, it will start.
It will come back on. Yeah, absolutely. So with the batteries as well, guys, important that you can't go below the SOC level. So it's a 7%. You have to have some capacity in the battery. You can't go below that. It's always the same thing. Yeah, 5%. But this is why I advise to have this charging from the grid options activated, because if you are having a cloudy days, right, 4 or 5 cloudy days continuously, so in that case, you don't have a surplus energy to charge the battery. So that situations can happen, and it can drop below the SOC level. But what the BMS will do, BMS will grab a bit of an energy and make sure that it's always keeping at minimum SOC level. Because if it drops below the minimum SOC level, you might need to get an external charger. So BMS always try to keep the battery at that minimum SOC level. But if you don't have that charging option from the grid is enabled, if you haven't enabled that, then we can have these sort of situations happening. Yeah? So it's always good practice. Time of use option is still not available, everyone. But we are working on it. It's not a big requirement at the moment in Australia as well. Time of use. Time of use means you can keep the SOC level when you want to discharge it, when you want to charge from the grid. If you have a different tariffs in the States, then you can also do that sort of settings. We are working on those, but it's not a big thing at the moment. All right. What's the time now, James? 1:50. So Jay is joining us at 3. Okay. Just while we are on the presentations, and then we'll show you guys how to connect those cables. Wanted to cover these circuit diagrams we got for the backup functions, because it gives us a good understanding of how to connect the contactor or that backup box to the inverter's pins. I use this Zymo hybrid. We do have a quick guide made up for installers on how to implement the backup functions. Okay, so please let us know. I can also send it to you. We do have the quick guide available for Primo Gen 24 Plus and also Simo Gen 24 Plus. I like using this diagram because it's much easier to understand. So I'll show you how to read this one and show you how it actually works in the backup situations, right? So hybrid inverter, again, those pin numbers are different. But Simo Gen 24, the concept is the same. You'll be using those 3 pins on the orange connector plug. So just ignore this one here. This is a Gen 24. This is a Fronius solar battery. This will be BYD battery. But if you're understanding this diagram here, this is our main switchboard here. This is where the lines are coming from the streets, and you've got the utility meters. This is your main switch, and straight after the main switch, everyone, smart meter. Okay, so you've got a Fronius smart meter here as well. Now, after the smart meter, what you're going to have to do is you're going to have to split the circuits, right, into the non-emergency, and you've got emergency or backup loads. This is why that AC contactor is useful. Okay, so we got the AC contactor with the 3 normally open contacts and 1 normally closed contacts. Okay, so that contactor you use to split the circuit. You've got the backup load here. This is the coil of the contactor. So this is the coil. And we are using the normally closed contact of that 12-volt relay here. Okay, so that relay and contactors are communicating with each other through those contacts. So K1 is our main contactor and K3 is our relay. Okay, so always please remember in the diagram, same with the Gen 24 Plus, K1 is our main contactor, K3 is our 12-volt relay. So it's the same thing there as well. James got the backup box. You will see the 12-volt relay there too. Now the relay comes with a normally open contact and normally closed contact. Contactors will have a 3 normally open, 1 normally closed. Now, normally close of the relay needs to be connected to line 1. Okay, so always make sure it's connected to line 1, the normally closed contact of the relay. And it goes through this coil of the contactor. A1 and A2 is the coil, as you probably know. That's always represented as A1 and A2, the coil. And on the inverter end, everyone, this is a normally closed contact of the contactor. Normally closed contact of the main contactor. One of them is one end is connected to this pin. The other one is to there. We do have the quick guide for the Gen 24 as well. Please have a look at it, and it will have the different pin numbers. Okay, but the same concept. Again, the relay is connected to pin 0. The other one is connected to the negative. We also have the negative pins there. K3 is the normally open of the K3 relay is 1 pin, and the other one is again the negative. So just always remember K1 is the main contactor, K3 is the relay. Okay. Now, what happens when we have the backup situations? How it's going to work? In the on-grid situations, so on-grid situations, what will happen is this contacts will be pulled in. Okay, so this contacts will be pulled in. All the contacts will be pulled in here. Now, what will happen? How the PV energy is going to flow from the inverter. So these are the inverter's line terminals. So we got L1, L2, L3. If these contacts are pulled in, the energy is going to flow from here to some of the emergency loads. But also because these contacts are closed, the energy also going to flow from here to some of the non-emergency loads too. Okay, so that's how the PV energy is going to flow. What happens is when the grid is disconnected, this one here, smart meter, everyone, is going to have a blank display. Okay, because smart meters also runs on the grid. So as soon as the grid is disconnected, it will have the blank display. And that's how our inverter knows that there is a off-grid situations happening, because our inverter is not going to get any values from the meter. Okay, so if it doesn't receive any values or any signals from the meter, it knows that there is an off-grid situations happening. Okay.
What's happened if the meters get faulty, like suddenly it's switch on the emergency straight away? Just like something happen with the meter.
It may trigger that as well if there's an issues with the Fronius smart meter. But unfortunately, we haven't had many issues with the smart meter. I'm hoping that it will probably stay like that. But it may trigger it as well. And if there's an issue with the smart meter, if you've got an export limit is also not going to work properly because smart meter is the feedback loop. Okay.
And I'll show you on the pre-light box later, but there's a couple extra 12-volt signals as well that confirms that the contactors have switched over.
Yeah. So there is always a feedback loop as well. So those are the contacts used for the feedback. So it needs to know when that one. So what happens is when the grid is off, make sure whenever you're testing it, when you are simulating the off-grid situation, please make sure the Fronius smart meter's got the blank display. Okay, because if it doesn't have the blank display, then this backup function is not going to work. What sometimes happens, installers in Australia, they install the smart meter here. Okay, on this side of the contactor. So the smart meter is always on. If the smart meter is always going to be on, inverter thinks that it's not a backup situation. The grid is not disconnected, right? So that's why it doesn't go into the backup mode. So please make sure your smart meter is at the right locations whenever you are doing the backup function. Otherwise, it's not going to go into the backup mode because if you install the smart meter here, the energy is flowing. This one are open in the backup situation. You're separating this. Meter's going to be running and it's not going to go into the backup mode. Very important, guys. If you want to simulate that backup situation before leaving the site, this is how you do it. But make sure the inverter's Fronius smart meter's got a blank screen. Okay. Other mistakes as well we found sometimes that these output AC connections from the inverter connected on this side of the AC contactor. Okay, not this side of the AC contactor. So please always make sure that your backup loads is on this side of the contactor, or this AC terminals are on this side of the contactor. Because what will happen here, guys, if you connect the AC here, what will happen? Yeah, I mean, what will happen is in the outage, no power, the smart meter is also going to be on. It's not going to go into the backup situation as well. And even if it goes into the backup, it's not going to supply to the backup loads, right? Because your energy is going to flow from here to there. So really important where you connect your AC out of the inverter to. Make sure it's on the backup load side of the contactor. Then it will work really well. Okay, so that's how you read that circuit or circuit diagrams. We do have the Gen 24 Plus. We do have it. We can send you the copy of that. But any questions, more than happy to answer those questions. But these are the common issues that we found, and it doesn't work in the backup mode. Okay, any questions about the circuit diagrams or any other things that you would like to know about the backup? No? One more slide about the backup there. It's this one. Here, so in the backup, what will happen is it can also work in an unbalanced mode as well. So per phase for the Primo Gen 24, it depends on the inverter size. But for the SIMO, it can only do 3.68 per phase. Okay, so depending on, especially in the unbalanced situation, it can do 3.68 per phase. Okay, so that's the maximum you can get out of the inverter per phase. Okay, so if you are looking for a bit bigger loads as well, it may go into the overload sort of situations, right? So please make sure your loads are not more than 3 kilowatt per phase in the backup circuits.
So it will provide an unbalanced output.
It will go 3.68 depending on what's the demand on that phase, but cannot go more than 3.68 per phase.
So if you have, say, 6 kilowatts of PV generation, 0 draw on one phase, 3 kilowatts on the next, and 3 kilowatts
on the
other,
6, yeah.
It'll
Yeah.
provide 3 to each.
Yeah.
And 0 to the third.
Yeah, it works.
Do that in grid mode.
In the grid mode, no. Because grid mode is a utility they don't really like. it has to be balanced. Yeah.
Is there a switch we can accidentally forget to turn on?
There is no switch, unfortunately. It's all software based, I think. But yeah, 3.68 is the maximum you can get. The reason we always cover this slide, because some installers as well, they connect really big loads like the induction motor, a water pump as well. You can definitely connect water pump in the backup circuit too. Look at the specifications, how much current it requires, and you can definitely give it a try. But induction motors, as you know, it requires a bit of an inrush current, so inverter may not be able to supply that. Okay, so why we cover it.
If it's on the frequency driver, or then that's not on the frequency driver, they don't require so much inrush current. Is it working this way, or
Yeah, but
Soft start.
yeah,
Usually soft, yeah.
so it's got like a frequency driver. It's soft start, so it requires less current. Is it that one? Yeah. Yeah, depending on how much current it can require. So 22 amps is the max you can discharge.
if it goes over that 22 amps, it just obviously it trips off in the inverter, and then what's involved with the reset of that?
It will continuously monitor that, and then once the load is below 3 kilowatt or 3.8, it will fire back up.
And then you can manually set how many times it tries to reconnect before it just stops.
Okay.
Yeah. The best way to, no, unfortunately, it cannot be reset. No, the inverter will continuously monitor that, what's the load on each phase, and then after that, it will run again. So 3 kilowatts. So that's happened as well. Sometimes installers call and say it's not going into the backup mode for some reason. What we do is we get them to switch off all the loads, all the breakers, and then switch on one by one and see which one is causing that sort of situation. So you can always start with that as well. Turn all the loads off, and then, yeah. Okay.
Is there so I've experienced with other products where the user is such a low user that they have, like, say, a 100-watt draw. Will that still provide power at 100 watts?
Yeah. Yeah, definitely. Yeah. It's just when you are looking for a really high power, so high, big electrical consumer, then we're going to have this overload situation. So with the overload situation as well, it does give us the error code. So with the error code, we can definitely say it has gone into that situation. Okay. Alrighty, guys, really good sessions. I think what I'll do is now we're going to divide you guys into two groups, maybe group of 10, and then I'll show you guys all this insight of the inverters, how to connect the cables. Let's have a look at it, all those terminals, and if you have any questions, let me know. So let's do that. Maybe group of, I'm not sure how many people we have here. Just the front row and back row. I think that's probably the easiest way to sort of go. So maybe you guys, the first two rows, if you want, it's going to come to the inverter. I'll show you how to connect all the cables. Sorry, I'll move this one out of the way too. Yeah, thank you. So this is the mounting bracket. This is right out sitting on the top of the box. This is how it looks like if you want to just have a look at it as well. These are the designated holes here. Pretty straightforward. The arrow is pointing up.
Put it back in the box.
Yeah. So maybe I'll get you to just remove the front cover. It has got two screws here, guys. Again, 180 degrees lock-in screws, so you don't really need special tools. You can always use a T20. Have a feel of how to just remove that screws. It's a 180 degrees anti-clockwise and then unlock the whole thing. Yeah, beautiful. And the whole cover comes off. Okay, so this is just the front cover, guys. Nothing there. It's a bit of a mesh there in the front. Big heat sinks. Okay, so here this is to dissipate the heat, but we also got a fan here as well, everyone. As you can see, if it's going to make a noise, it should make a noise now as well, but it's much quieter, less noisier too. What I'll do is maybe you'll want to have a feel of this sort of like couple of screwdrivers, and maybe you want to just have a feel and see how to remove those screws using that, because it's probably
Feel good? Yes. Bit different to a normal screw.
Screw, isn't it? Yeah. So maybe I'll get you two as well. Just have those couple of screws, or we just this one here. Sorry. And there's a one here. Okay, maybe then if you also wanted to just have a look at, and then maybe just lock it in and then see whether you can lock it back on, and just have a feel and see how they, because if you haven't, yeah, that's locking in. You will see a bit of a clicking there as well, so you know it's clicked on. It's got 5 screws here. Okay, would you like to just have a unlock as well? Just maybe do a couple and see. Yeah, but maybe I'll get him to do a couple as well.
Oh, these you guys, you made them?
Yes.
Oh, got some printed.
Yeah.
Oh, that's nice.
That's how, yeah, for force, it gives a, like you can hear the clicking, you can feel it.
Yep. Yep.
Okay, thank you. Would you like to just unlock the whole thing?
Just in case.
Yeah. This one's already done, I think. This one's, we are undoing this too. So you don't have to remove them, all of them. You just kind of undo it, and then as long as we don't lose them. Yeah. Alrighty, so this is where you're gonna have to connect all your DC and also the AC cables. Okay. Maybe if you can just come a bit closer here as well. As you can see, guys, that the inverter part is just this one here. So the whole inverter, this is where the magic happens, right? It converts the DC energy. It also does the charging and discharging. Sometimes installers saying that your inverters are too big. But if you look at the inverters part, it's just only this one here. We wanted to make it more spacious here so that you've got enough room to use, play around with the cables, or this is the reason why it's bigger compared to our competitors. But we want to give you guys enough room here, okay? So then you can put in the cables, have got enough space here too. So maybe I'll get one of you guys to disconnect this one here, because one of those as well, maybe just not this one here, don't disconnect this one because this is live, guys. Maybe we can also switch off just in case. So yeah, this is how the plug is. Maybe if you want to disconnect this one here, might maybe get you to.
I get it.
Yeah, so there is a little clip here. You can see it, just, and then you press it.
Oh,
yeah.
I guess so you can fit your off and then plug in that way rather than leaving it in, I guess.
Yeah, so you're gonna have to unplug it and then plug it on. So if you would like to connect your DC connections, just lift this one here, and then you insert the cable, and then it will just lock it in. So have a feel.
Did you say that was 16 mil?
16 mils, yeah.
Is it Wago, is it?
Wago.
Yeah.
Already had a look at?
Yeah.
Oh, you wanna?
Just wanted to see the okay. Yeah.
So you just
pretty tight, yeah.
Yeah, it's pretty tight.
Yeah,
It's got a
open.
spring there, so it's just gonna lock it in.
Yep. Yeah, we've done that before, so.
Yeah.
What voltage are those BYD batteries?
200 to 400. They're high voltage DC batteries. So
200 to 400?
that's like, yeah, how many stack? Yeah. So different voltage range for different energy range.
And that's the difference between the S and the M as well, it's the voltage.
HVS and HVM.
Yeah.
There will be a difference with the voltage as well, but HVS is mainly if you are looking for a high power. Whereas HVM gives you more density.
Yeah.
It gives you more power. The other ones gives you with the
higher voltage if you want that power with your 16 cable limitation, aren't you?
Yeah, but the power will be the same. It depends on the voltage and also the current. So which one you are changing? If you are getting with the
You want a
HVS,
higher voltage so you have less current on your 16 cable.
yeah, so they can definitely handle. I mean, 16 mil should be more than enough to handle.
It shouldn't even need
Case volts. Yeah, it's like a 4 mil can handle 1000 volt. 4 mil DC can easily handle 1000 volts.
Yeah, and if you bump it up to 600 or 800, you can run 100, 200
Probably
meters.
never use 16, maybe 10 mil max in any. Oh, no, it's the other way. Yeah, no, it's the right way. Yeah, the right way. So we just click. Yeah, yeah, perfect.
Do you guys have any installed?
So, as I said, the AC terminals are inbuilt here, guys, for the PV point. Okay, it does have the earth terminals here as well. So we provided quite a few earth, here the terminals. As you can see, 416 mil. I think there's a 10 mil too. A couple of them 10 mils. But you're gonna have to earth one of them to these earth terminals. Okay, if you are doing the PV point, line neutral again earth, and then you build a GPU there. This is the AC output again. But yeah, it's very important here as well, guys, that if you can connect the AC in your office and do the update in your office, that's always a good practice. Okay, because this inverter runs on the AC supply. Even the 3-phase inverter, as soon as you connect the line 1, it will switch on. Okay, so connect this inverter to your office internet or internet connection, because you don't want to rely on customers' internet to do the update. So we got this flexibility. Just open it, update it, so you don't really face any issues at the site. Okay, always good practice.
Are you still doing the USB updates?
Not on this one, unfortunately. Yeah, there is no USB update available on this in this one. Good question. So unfortunately, there is no options available.
Hence why I said to do it at site before you go, because depending on how old the unit is. But I'd say they'd be pretty new if they're only just coming in.
But the thing is, software is always
always
renewed.
changing.
Yeah,
New
software.
product's probably going to be less.
Yeah, and we don't know how long it's been sitting there in the warehouse. So usually it takes 2 months on the ship as well before it hit the shores. So it's always a good practice. And you don't want to rely on the customer's internet, because it's always a bit slow, not good speed. It's good practice. It's these pins are also the same. It's the same as the one that you're using on the snap inverters. So you just all the signal inputs. Yeah, so we don't really need big cables. It's just a signal. There. This is where you connect your smart meter. Smart meter pins are called D positive, D negative, negative on the snap inverter, but this one's called M0 positive, M0 negative. So, and it's also got the Modbus pin for the battery as well. So you do connect the battery here. Okay. So for the communications, yeah.
Does the BMS on that high voltage battery shut down if it loses comms?
It will, yeah. It will go into the standby, yeah, not getting any signal. So then they go, oh, I'm not getting any communication from the inverter. Inverters also produces an error code.
Voltage system, I think in 10 minutes of no comms, it shuts down.
Yeah, so it will definitely come up with an error message. Error message as well, guys. It's four digits now with the snap in this one here, whereas in the snap inverters we have 3 digits error code. This one's got 4-digit error codes. Okay. This is what we call the pilot.
Is that an indication that there's a lot more errors?
There's a lot of smart meter related errors, monitoring issue related errors. You've got inverter related errors. You've got the battery related errors as well. So it's going to be a lot of errors, registrations in the memory chip. But this is the pilot. What you can replace the pilot on this inverter. You can also replace this bit here. This is called the power unit. And I guess fan as well. You can replace the fan too, just in case of an issue. But in terms of replacing this pilot, you just a couple of screws. You just undo it, remove those screws, and then it's plugged onto this. There's a plug at the back. Just it's just a card. Yeah.
So if you're replacing this inverter, do you have to take this whole thing off the wall? There's no way to keep the DC.
No, so you just remove this one here. This bit, those connector plugs.
Yeah, because in New Zealand we don't have isolators on the roof, so we can't actually turn it off. So you probably have to.
There's a DC isolator here, but this one
you
here.
have to we're going to have to put a DC isolator here because we don't have them on the roof. I know that SMA do that, but because no one puts them on the roof. The old snap inverter is fine because you can take the inverter off.
Take up the old inverter.
Touch the wiring. Yeah, that's a shame. Yeah. I guess it's hard to the different
I think what
is that whole piece coming? But yeah, I wouldn't be comfortable leaving those DC cables exposed there.
I'm not sure whether this one is gonna disconnect that as well. The
That
whole thing.
piece came out, then potentially that piece there could fit right through.
So you couldn't really leave it like that while you did a repair for the customer. I wouldn't say that's a form of isolation.
Yeah, I just have to double check, guys, because I'm not sure whether it's going to isolate the DC using this DC switch or not. Whether
It's not going to isolate.
I've seen them installed in Australia and no one else is putting them on, but they have an isolator on the roof.
Yeah,
So
but then no one's going to get on the roof to disconnect the PV, right? So or isolate the
If you're
PV.
going to go on there rather than pull that, if you're going to replace the inverter.
Still, I don't think so. We probably would get them to jump on the roof. It's a time-consuming process. So I don't know how it works, but that's a good question. I'll find out. I'll find out.
There's no way doing it.
Yeah, you have to. But I guess,
Yeah.
say you replace you're not going to take the inverter anywhere. You go to site and replace it, but maybe you might be able to just pull that to the side while you do your work.
No, it's a good question.
Isolate, I would say.
Yeah, no, definitely a good point you made here because we want to know, we don't want installers to jump on the roof just to replace it, but we want to make sure they go there, quickly remove it, all the parts, the connections, and then install the new one. We don't want them to jump on the roof and spend half an hour, 40 minutes. It's just a 10 minutes job. Yeah, no, definitely not.
Follow it up. Yeah, I might go on Aussie
Yeah,
and ask them. Yeah,
definitely.
See what the guys are doing at the moment.
For sure.
Do they still need to put one on the roof there?
Yeah, we're still doing.
Yeah.
But there's a bit of a debate going on at the moment, so they may remove it, their regulations from the
But there still
new.
needs to be some sort of isolator. So if there's MC4s on the roof and a plug-in thing here, and you need to replace the inverter and it's out for a week, you can't just disconnect the MC4s. There needs to be some sort of isolator, whether it be external here or up on the roof.
But no one installs the isolator next to the inverter in Australia. So,
Because you have one on the roof.
yeah,
Yeah,
but then
It must go up on the roof.
they don't.
DC, you've got to hear anyway.
You wouldn't want.
Yeah, no, they don't. They definitely don't go onto the roof to switch off to isolate the PV array. Definitely not with the snap inverter because as you said, it's easier. But for this one, they may have to, but I probably have to double check with them. Even with the other inverters as well, I don't think so. They jump on the roof to isolate the PV array. Other inverter brands.
These isolators.
Yeah, compliance. No, they don't have it. Yeah. Not all of them. Yeah. So, but yeah, because we don't really want installers to jump on the roof because that's the whole
And
point.
obviously the battery has an integrated battery isolator. Right?
Yes, yeah.
So you don't have to do it.
It's a breaker. It's not an isolator. So on the battery, there's a tiny little switch that you have to use to switch off and switch on. So the breaker is lockable, but the breakers is going to trip if there is an overcurrent situation. So this is the reason why there is a breaker
On the battery.
on the battery. Yeah. So if you use that breaker to turn off the battery, then it's not going to be on for another 15 minutes. So it thinks that there's a false situations happening, but there is a way around it to kind of trick it. So then you can flick it back to the on position. So it's in the BYD manual. So please always use, if you are installing the BYD battery, there's a tiny little switch. Just use that one to switch on and switch off.
So do
Yeah.
installers put a isolator in between anyway, between the battery and?
Again, it's with these battery standards 5139. I think it depends on the distance between the inverter and the battery module or battery bank. I think if it's more than 5 meters or 7 meters, then I think you do require to install the separate DC switch or isolator for the battery. So depending on where you're installing the battery, if it's right next to or underneath, then you don't really have to. Okay, but it's in the battery standards there. Now, the question is, guys, like, as you can see, it's a different terminals here. How do you measure the voltages? Like, if you want to measure the voltage, where do you measure the DC voltage, AC voltage?
Be on your DC screw terminals on your old.
Yeah, definitely measure it. So if you haven't seen this one,
Will that allow a Cat 4 connection in there?
1
millimeter?
There's a push the.
yeah, there's a little clipper here. So yeah, you can just probe your multimeter here into those holes, and it can measure the PV voltage. Okay, same thing here with the AC2. Battery terminals as well. Please do not connect anything if you are not installing a battery straight away. Just leave those one blank. But this is where you can connect your batteries, high voltage battery. What else? Knockouts here, as you can see, there's quite a few knockouts here, depending on the size of the flange. And the knockouts, few knockouts on the back here as well, guys. So at the back entry.
Do you mean more like you can actually knock it out? Guys,
Yeah.
hit it with a chisel and actually.
Use a proper, not a hammer and a chisel, guys. Not a hammer and chisel. Not a hammer. Use it's about 25, 30 kg.
Yeah,
not heavy at all.
You can get your screwdriver and you can tap it out. But obviously not that one. It's whole sort.
No, unfortunately, yeah. If you can't do it proper, tool, the knockout tool that you can get. Yeah.
It's IP66.
This one is IP66, guys. So definitely can be installed. There's a label here with all the specifications, including the V code and serial number. So you will need the V code for the registrations of the system on SolarWeb. So please take a photo of this label and record it for your future reference. Okay.
What's the IP rating on those BYD batteries?
55. So they can also be installed outdoor. But it's a battery installations. If you can find a space inside, it's always a good installation. However, it can definitely be installed outdoor to IP55. Yeah.
It's a lot of money outside.
Yeah, a lot of money.
Outside.
Yeah. If you don't have a choice, then definitely an option. But yeah, just indoor location is the best one. Alrighty, any question? Sorry?
Are you looking at using any other battery?
A really good question, guys. Really good. So at the moment, this one is only compatible with the BYD, HVS, and HVM. We are working with another battery manufacturer, LG Chem. They call LG Chem, but they are working on the new generations of the batteries. So there's also going to be a modular design.
Which aren't available in New Zealand at all.
Yeah, let's not go there.
Right. Okay. So in Australia, it's going to be available end of this year. End of this year, the new battery module from LG. End of this year. Looks pretty cool. Really, it's also got a modular design. So the old one, you know how it's only a one piece, but this one's have a modular design. You can mount it on the wall.
They want nothing to do with New Zealand. They won't even let anyone parallel import LG.
All right. Okay.
Wow. It's completely gone.
Right. So yeah, unfortunately, there's just a couple of partners. Yeah, because we don't want to get too many of the battery partners as well. Then what happens is battery manufacturers, they go, it's your fault. You know, you go, yeah, no, it's your fault. So at the end of the day, the installer is going to be in the middle and stuck in the middle. We want to get battery partners. They provide a proactive service to us. So as soon as we approach the R&D department, we get a good response from the R&D department as well. And this is the reason why we chosen BYD as a partner, because they've got a local support in Australia too. And we don't want installer to just going back and forth and go, it's your fault, it's your fault. We just want to provide quick solutions. And that's always the reason why we don't have many battery manufacturers on board, just the good ones, you know, have a local support.
Is there a main driver in going to high voltage versus low voltage? Three-phase?
Yeah, so good questions. With the high voltage, I guess it's definitely going to reduce your system cost as well, because if you got a 48-volt battery, then you're going to have to use the large cables as well.
The cable, I'm so used to 48
Yeah.
system, so I'm kind of
And-
used to that large cable
and-
size.
and- yeah.
Trapped into it. Be more efficient with the high voltage.
High
conversion rates too.
absolutely.
If you're using
That's-
230 volt power and your battery's
And-
closer to 230, it's
And it's a DC coupled battery, so it's charging from the DC energy. So DC energy is, again, if you are connecting the panels in a one string, you're going to have the high voltage, right? So it's a high voltage batteries, DC coupled.
configurations.
Yeah.
There's gray area with even protecting that cable between the battery and inverter. If it was like a PV array, it should be protected, right? From your battery to your inverter, being 400 volts.
It needs to have an earth fault alarm on it too, doesn't it?
Yeah.
Is that all built in? Is it?
And the battery, yeah. You'll get it, yeah. Earth fault. Because the battery is just replacing the PV array in the evening, isn't it? So it's the same. PV array, you've got working during the day. Battery is replacing the DC energy source basically in the evening. That's the only difference. And those battery modules are connected in series. It's like a panels. You connect them in a series, you get high voltage, a bit of a current. Okay.
When you're putting a high voltage, like, did you say that these ran right up to 400 volts?
Yep.
So that's going to...
And-
450.
Yeah, and that's why you need a separate tracker as well, because it tracks the maximum power point on the PV array.
Number of panels in a string.
And then it's not a fixed voltage, so it's got a range, and it will pick the maximum voltage and maximum MPP point. So you need a separate tracker. It needs to track that curve again and pick the maximum power point and then start charging the battery. So that's why we have a separate tracker. Okay, guys, this is a bit of a few things that hope you guys got a few takeaways as well, got a good understanding, but we are here to support you. Any questions, please let us know. A bit later on, or Taspac is also here to support you guys. We do have a tech support department in Australia, so you can always contact them too. We've got 9 engineers in tech support, so they're here to support installers. Yeah. Alrighty. Anyone? Okay, thank you. Thanks, guys. We'll get the other group. Voltage is okay. Sorry, I'll just quickly grab this cover. Alrighty, guys, here we go. It's getting close to this inverter as well. This is the front cover. Oh yeah, so maybe if they would like to join us as well. Yes. Yeah. Let's go here. All right, maybe I think we're just still waiting for a couple of those.
I think it's a smaller group, Sam. About 2 thirds came up before.
Okay, beautiful. All right, guys, so this inverter here, the way it's packed, you sort of like got this one here on the top. You also got the inverter, and this one will be right on the bottom. Okay, so you bring out those pieces one by one and start installing the inverter. So this is the mounting bracket. We saw that in the slide. This is how it looks like. As you can see, this is the arrow pointing upwards. So if you go installing
Sorry to
version.
stop you. Are these tabs, is it mounted on these tabs here for just vibration harmonics, just to keep the sound down?
It is, and also if it's got an uneven surface, see how they are very
They
flexible.
flex, it'll just...
They're really flexible as well. So that's why we have got this one in the snap inverter and also on this Gen 24 Plus inverter too.
On there as well. So if you put a screw there, it will help the screw.
Yeah. So I'm hoping that none of the installers going to do that, but you never know.
Sure,
some of them, someone will put like
people.
But that's why someone's actually put the screws on this one here as well, thinking that this is where you put the screws on, so he jammed it on.
Yeah,
and it wasn't sitting.
Thing back and
he didn't
fail it
sew.
all up.
But this is how the mounting bracket looks like, guys. Yeah, and that's you can click on this inverter bit here. So see how this click on this bit here.
Yeah, a problem like that is a metal part. Is that like a double insulated rated? Will some inspector will ask for earthing the plate also?
I mean, there is a earthing here on the inverter as well. So which I'll show you where the earthing is on the inverter.
Working clips on that.
On
this one. Yeah, the clip that is
The connection to the earth terminals. Yeah.
On the underside, is there any metal part?
It's a good question.
Once it's mounted, everything.
No, it's a good point. Definitely a good point that you made. So I'll ask them, see whether there is any provisions there. Or we can actually have earth terminals here somewhere that you can just connect your earth cable straight to the.
If the inspector's going to pull up.
Pull up, yeah. Nah, just.
Full plastic because there's no double insulation sign on this one.
So this. Yeah. So this one here, guys. I mean, this is the DCI. So.
You've had the inspector pull that up.
No.
Yeah.
I think in some installers. Yeah. This one's got an inbuilt isolator here, guys. So if it's on the on position, you can't remove this front cover. Okay, so it has to be. It's lockable as well. I'll give you to have a feel of this 180 degrees lock-in screw if you haven't used them before. Or seen that one before, just have a feel. Just clicks on. You don't really have to apply too much of a force.
No.
So if you can remove this front cover, please, for me. Yeah, so you can definitely feel it. It's just easy. Maybe you can also play with this couple of screws, see whether you can unlock those ones. I'll get you to do couple as well. You can do couple. Yeah, so that's it and done. You can feel it, yeah.
Thank you so much.
Yeah, no worries. Thanks for coming down, mate. Nice meeting you, and we'll stay in contact. Hopefully, we'll see you soon. The border's open. Okay, all right, mate. Have a safe flight. This one here as well. You probably want to play around and just see, have a feel, lock it and unlock it. So basically, it's just like you don't have to apply too much force. It's just you can feel it. And then this is where you've got the connection compartments. Okay. So
trackers, this is these here.
So I've got PV1, one is the tracker one, PV2, PV positive. So those are the positive terminals. These are the negative terminals. Yep. We have a positive terminal for the battery. We have a negative terminal for the battery. Okay. So if you're not connecting the battery straight away, please do not connect any DC to there.
What size terminal feeds you got for the battery?
So guys, here there's a pin here that you have to press, and then the whole thing will come up. So
right.
And maybe you can remove this one here.
Yeah. Cool.
Okay, and you just lift this bit here, and insert the cable, and it just clips on. So maybe have a play around with this one. Special plugs.
And what did you say? And that'll go to 16 mil on the battery?
16 mils, yeah. Yeah, but I guess 16 mils you won't require because you can only have a 22 amps.
Yeah. Okay.
So
yeah,
probably
yeah,
10
yeah,
mil is
yeah,
probably
yeah,
the
yeah.
16 mil max. Yeah,
So it's just
no, it's not gonna go. Maybe 6 mil as well, probably max.
Which one is the buck?
That was why I was asking about the ferrules, because I've often wondered if these actually get a better contact without being ferruled, in case it
Just maybe not sitting right. Yeah, just an
they
angle
can
or
just
something.
squish
Yeah.
a bit better, you get better surface.
Yeah. Have you seen it? Okay, beautiful.
Is it required boot laces on
Yeah,
this one?
it's
It's called
Yeah.
If you can, just in case if it's not sitting properly or if it's not squeezed on properly, so use the boot laces for proper installation. So that's for the positive here. Sorry.
Yeah, that was good. No, that was a good question.
Reverse polarity. It may come up with a reverse polarity, right? So the inverter will produce a. It
Is
is
it got
possible.
reverse polarity
Detection.
on
Yeah,
the-
yeah.
but not the battery?
Battery as well. Well, I guess probably not on the battery.
Cover off that bad day.
Yeah, that's why I guess color coded, maybe
Yeah.
red and
I've still
black or
seen it
something.
once, getting put
Yeah,
round the
no.
wrong way. I don't know.
No,
One of the boys did
with
it.
you. Yeah. So this is the connection compartment here, guys. As you can see, the inverter area is just this one here, right? So sometimes we get a feedback from installers as well. The inverters are really big, whereas the competitor inverters are really small in size. But if you look at the inverter compartment, this is just this one here. It's really tiny, right? The reason why we want to make it a little bit bigger, because then we want to give you guys enough space here so you can play around, enough room to put in the cables. Otherwise, it's sometimes hard to play around with the cables too. So it's very tiny.
The wall print will not be smaller if you put an AC isolator in this isolator.
Oh yeah, if you really wanted to have some sort of a DIN rail mount there as well, you can definitely do that as well. Just
So can you bring your DC in through a plane to screw and have it, so we can just keep the DC in solid conduit and not have anything? Because that's going to come inside that shroud, isn't it?
no, it's gonna.
Oh, is that off to?
Yeah, so you still be able to.
You're allowed a bit of DC
So from here,
exposed.
yeah,
300 mil, but it would still. That's my one and only thing with the Fronius. It'd be lovely if you could swap that out, because I would rather just take them all in straight in the hard conduit. There's just certain, on a commercial basis, certain environments where I'm like, I just don't even want that DC cable there. Anyone could have a bit of machinery or something metal or something whack past it, and it would just protect.
Yeah. So
exposed.
If you do use this knockout here,
or
then
it's got to be protected. So I've been putting guarding up.
Yeah, what happened if you use this knockout here? It cannot be used, or what?
I don't know. It's fine, but it's then you're just getting into the comms area, aren't you?
I think another knockout here that could be.
Yeah, there's another one, and there's. I was gonna show you.
That's the one I wanted to see.
Okay, and there's another one on the back as well, guys. There's another one for the back as well. So here we go.
Sweet. And that's not going to affect the IP rating you're
Happy with that.
Yeah,
happy with
okay,
that.
right.
So,
we're covered bases.
so there are a few options, guys.
Yep.
Sorry, yeah.
Oh, yeah,
on the
one,
side.
you might really want to have two.
Yeah.
So this
the
is
same side.
this is mainly for the AC connections, and this is for the DC. So you can always
one or
use.
two on that side.
There's one. So, but on the back as well, there's a one.
But which is gold. The back one's gold.
Back ones, yeah.
If you make two penetrations on the side, is it compromise the warranty?
No.
Or it's like
No,
not
that should be
use
fine.
the
Yeah,
route
IP.
to just make this.
IP is gonna.
Two strings coming, two glands on the side.
But you can use a one glance and run the full cable, is it, or it's not gonna be?
It's just
If it's DC, you'd be a plane to screw in your conduit going. You wouldn't even gland it, would you? I just
Beautiful. All right. So again, with the positive is here for the tracker 1 and tracker 2. We got the negative is here. So just always be look at those pins and connect the right cables, okay? Because otherwise it will come up with the reverse polarities. Now the fan, guys, this is the fan here. Have a feel, like if you just spin it and then
brushless.
it's not gonna make noise. It's much quieter compared to the Snap Inverter series.
Does a brushless
Less
motor?
noisier.
What type of motor is it?
Good questions. I don't have that info. It's probably definitely
These days, it feels it.
The old
Yeah.
747 wingtips.
Yeah,
and stop the turbulence.
That comes straight from the.
Yeah, so it really draws the cool air quickly, and yeah, so these are all the heat sinks here. Other thing as well, guys, that this is the pilot, okay? How many parts can be replaced in this inverter? You can replace the pilot and also the whole unit, the power unit. Okay, now one of the guys from that group asked a really good question. He's saying, how do we isolate the DC if we are not installing the DC switch right next to the inverter? Whenever we have to service the inverter, whenever we have to replace the inverter. So that was a really good question. In Australia, we got isolators on the roof. So, but we don't want installer to jump on the roof and then isolate the PV array from the inverter because it's a time-consuming process. I'm sure there is a way to isolate the PV array.
At a commercial where we've put these in, and from a servicing point of view, or if we want to do anything, accessing the roof is too high.
Yeah.
We've come straight in because it looks smarter and it's keeping it simple. I prefer less connections and that going through, less terminals to come loose or anything like that. So we're straight in. But looking back on it, I think from a service point of view, I'm like, I think I'd rather roll with some DC isolation.
Isolators, yeah.
You can't throw a blanket up on the array. I can't get up there and disconnect the strings.
Also, if you got a separate DC isolator, it's gonna help you with the troubleshooting as well.
Yeah.
If one of the string is down, much easier to troubleshoot because then you can do the short circuit test. You can do all kind of tests as well. Now, with the short circuit test as well, one of the guys asked me questions in Christchurch saying that can we do the short circuit test here? Please do not do short circuit test here because these terminals cannot handle more than I think 22, 25 amps. Okay, so if it's a huge current coming through, it could possibly damage the terminals here. What installers do in Australia, they always carry a spare isolator in a van. So they always got a spare one. Disconnect the strings from here, connect that string to the spare isolator and do the short circuit test. Clamp it, So that's always a best practice as well. If you can carry a spare isolator in your van, I mean, you don't really need a isolator with a high voltage, maybe 1000-watt rating, and 20 to 25 amps should be more than enough if you are doing a short circuit test on one string. Okay, good practice.
And I still do it on the roof after the panels are installed.
Yeah, but it's like if you are finding a fault on a systems, then you don't want to get on the roof and do the short circuit test on the roof. Yeah, but some installers look in Australia as well. They like to install the separate isolator because then the troubleshooting becomes a much easier, less time consuming as well. Okay. All right. So that's the point. This is where you connect your smart meter. So smart meter pins are called now M0 plus, M0 negative, and negative. Okay. It's called D positive, D negative, and negative in a snap inverter, but it sets M. It stands for mode bus. Okay. That's why it's called M0 positive, M0 negative, and negative. And this is where you also connect your battery connection. Okay. So the comms connection from the batteries are connected
from the BMS.
From the BMS. These pins are used for the backup function, guys. There is some of the pin number 6 and 7 used for the backup functions. V positive used to supply the 12 volts to the relay. So
in the backup board.
Yeah, in the backup board. Backup board. So
and then the other ones are going to signal the contactor. Is it
correct? Yeah. So for the feedback of the contactor and also because sometimes it may well shut. Sometimes you never know, the contactors may well shut.
Yeah.
So we do have the feedback mechanism using some of those contacts. Okay. Here we go. Thank you.
Is that another dry contact? Is that a signal that we can use normally open, normally closed?
This one here?
Yeah.
This one jumper?
Yeah.
Very good question here, guys. Maybe what this one is used for, it's called WSD. If you look at the WSD here, it's marked as WSD.
Yep.
It stands for wire shutdown. Okay. So in the US, there's a regulations where they have to send a signal to this inverter, an external signal.
Yep.
so the inverter can shut down. In a case where there's a bit of an arc happening on the installations, or could be for any reasons. There's, I think, regulation in the US, where they have to send the signal to shut down the inverter. Okay, so in that case, you remove this jumper, and then connect those signal input from that device onto those pins. If you have this jumper a bit loose, the inverter is not going to work properly sometimes. Okay, so always please make sure that this jumper is connected properly inside the pins. But we do get an error message anyway. If this is a loose, we can always ask you to just check the jumper.
So can that then be used to shut down the inverter, i.e., like when we've got a generator on site or what have you, you can have it?
Possibly that can be done, but at the moment, on the snap inverter, we use some of those pins, the 3 pins plug.
Yeah.
But this plug is specifically used for, I think, that third-party device.
Okay, so that's where my head's going.
Comply with that regulation in the US, whereas in Australia and New Zealand, we haven't got it. But with the diesel generator as well, I think there is a pin. It's not on top of my head. You can definitely shut down the inverter whenever the diesel generator kicks in. So that option is available. Are there many installers where the diesel sites where the diesel generators are installed? Probably in farms or those sort of sites.
Commercial, depending on the commercial. So this is the commercial job that we had, and I was glad that we were using the Fronius because we literally just had to take a relay out of the Jenny. Running as soon as they put the 12-volt circuit on with their main switch, it just fired up, and then you can just send this to be the sensor change of state. Normally open, normally close.
Within a few seconds.
And then the inspector goes, yay! And we were happy. And it was so simple.
So some of the snap inverters, some of the snap inverters also installed in hospitals, right? The hospitals, they've got a diesel generator too. It is going to happen here as well, guys. Like, so yeah, in New Zealand, the utilities will not have to purchase the electricity from the grid operators. They can always just go to individuals and say, look, we've got a battery storage unit here.
Yeah, it's one down here. There's
That's not Frenchie, but great.
Can you hear that? Okay, there we go. Yeah, there's a little bit there. I just need to. Yeah. Is that got I think we've got some noise now.
Is there a gain switch on that? There's often a gain switch on the.
Is that, you sure it's not?
Battery charging part of the inverter until you start using it.
Isn't that in
Is
here?
that right? That's what I read on one of those now.
So you're talking now?
The inverter and it's possibly similar to.
Hello?
Try again.
Sorry.
So we can hear you. It's just really quiet.
But that's something we are working on as well, of course, to reduce the cost of the whole system again further. But we went with the DC coupled storage system because
The levels is very low.
Yeah.
So
we don't want to test this morning.
I tested the connectivity of the thing, and literally we had Sam's plug into the HDMI, and it was making
use
all
the high
on YouTube
voltage
on there.
DC battery. Someone asked why you're going with the low voltage.
Yeah.
Again, with the low voltage, efficiency loss is a bit higher, and also you need big cables as well. This is not low voltage, high current. So you need with large cables.
So that's
So the cost goes up.
It comes in through here. Maybe we should just get rid of the projector.
Yeah.
There we go. That sounded good. And then just plug this straight into the machine.
It's not a fixed. Yeah. So again, if you have the high current, the loss is going to be high because of the heat dissipation. So it's not a fixed voltage. That's why we use the MPPT tracker.
Okay, you there, mate?
So it tracks the.
just take that.
Should I start?
I'll just give you a quick intro and we'll go from there, mate.
Yep.
Hey, so this is Jay from Alps Power. He unfortunately couldn't be here today, but he's remoting in from their office in Sydney. So Alps are the service contractors for BYD for Australasia. Some of you might have talked to them before and some other stuff. So Jay's just going to run through a quick background of BYD and the HVM and HVS batteries. So take it away whenever you're ready, Jay.
Thanks, James. Hi, everyone. Unfortunately, I couldn't be, presenting this in person, but hopefully I get the, chances to travel to New Zealand next time. So today just gonna be like 30 minutes, talk about the BYD as a companies and the product HVS and HVM with Fronius Gen24 inverters. And so my name is Jay, and there's my three of our colleagues in Australian team in Sydney. And I'm working in the battery storage industry for around 5 years and 3 years with BYD. And I'm also doing a PhD in power engineering. As I mentioned, 4 sections, and we're gonna cover a little bit about the installation tips. But as you know, our battery is a modular design, so there's not really we need to discuss on the on the installations. Just few tips. First, I'm gonna play a short video, just show you what is a BYD battery and the brand or the series we call the battery box.
BYD Company Limited was founded in February 1995 with its headquarters in Shenzhen, China. BYD has 4 major industries: electronics, auto, new energy, and rail transit. On March 30th, 2020, BYD officially released the Blade battery, a huge step forward in battery efficiency. In 2015, BYD launched the first battery box product in Munich at an event titled Icefire. It marked the first time that the market had a chance to see BYD's revolutionary residential energy storage products. Driven to stay on the forefront of the industry, BYD listened to the market demands and continued to launch advancements to the product line. In 2018, continuing with successful modular design philosophy, BYD launched a low-voltage battery box in Australia and Europe. These amazing products helped us rapidly grow our footprint in the global energy storage market and answered customers' increasing demands for high-performing storage products.
For those of you you don't know what BYD stands for, it's actually built for your dreams, or we used to call the bring your dollars. So BYD. BYD is a very huge corporation, so it's not a small battery company, and it's founded in 1995 as a battery manufacturer. But later, you see the revenues growing, very rapidly going up in the past 10 years, and it's a company generally not really known for the Western countries. The main reason is the BYD cars or BYD buses or something BYD doing is behind the products is not familiar with the Western customers. But now BYD is producing a products that's either a cars or the battery storage. To the offer to the for example, Australia and New Zealand customers now. And first, hopefully BYD cars gonna be available very soon in New Zealand market. There's some companies already releasing this in Australia, but hopefully getting more to the New Zealand market probably in the next few years. And BYD buses, so if you actually travel to China, Europe, or US, you will see, or Japan, Korea, you will see the BYD buses everywhere. And in Australia, particularly in the airports, the electric buses they actually made, and it's a BYD brand buses. On the BYD battery. So as you see in the introduction video, everything on the battery cells is automated, and BYD is only few companies. I would say probably 2 or 3 companies is capable of doing a whole process chain between from the materials to actually building the cells, doing the development, and to produce the final product, and also include the recycling at the end. And you will see BYD is roughly 65 gigawatt hour per year. So the numbers, it probably doesn't make any sense to you, but this is number one battery manufacturer in China, the capacity. So basically is you can think BYD is for the battery manufacturer is, compare on the capacity or the quality, it will be either number one or number two from the Chinese market. So okay, on the market, basically, if you guys, I don't know if you guys have ever doing any installations or sell any energy storage to the residential market, but from the PV magazine, the BYD the whole residential market is gonna be getting bigger and bigger each year, and especially for the residential or the commercial market. So the customer, when they actually purchase electric vehicles, or they getting a larger family, but the electricity bill is gonna be really high, so they would consider to getting a battery to their solar systems. And also there's opportunity for front of the meter. This is for the service providers, so they make centralized battery storage as well. So in general, this is the 6 years of BYD battery box offered in Australia. I would say this is probably second or third year offered in New Zealand, and there are more than 160,000 units delivered. And for the new premium series, we offered from last year, so before the COVID, and there's already hundreds, thousands of units delivered for the new premium series, which is the product I'm going to talk about today. Before I go to the product, I would like to cover on some market share. So this is on the Germany research, which is one of the leading markets and where the BYD has the most sales in the globally. So from 2017, which is BYD just entered the European market, and roughly market share is around 3%. And the next year, we released a stackable design, which is unique compared to other manufacturers, and it grows rapidly to 13%. And in the following year, this is also Germany and Europe. BYD already achieved the number 2 in both major markets. And in 2020, so BYD keep the rank and keep the leading place in the Germany market as well. Some of the rewards that's received in the past 3 years. Okay, I'm gonna talk about some key features. And first, this will be the only products we talk about today. So the LVS and the LVL, they are 48 volts system, and they can be installed off-grid or on-grid. But today we're gonna talk about the HVS, the high voltage range. Roughly voltage is about 200 to 500 volts. And this will be the products we mainly discuss today. There's 4 key features about our the HVS and the HVM batteries. So first, BYD as a company, as we introduced, is not a small company. So once we release a product, we're not going anywhere, or we're not just saying, okay, we stop producing that product anymore. We're gonna be, when we offer that product, we want to be there for like a long term. So you can trust us as a big corporation, just like Tesla, LG. So we're the same size company here. And second, on the chemistries. So I don't know if you guys are familiar with the chemistry used for lithium batteries. So there's 2 major types. One is what we use for the what we call the lithium iron phosphate, which is used in our cars and buses, everything. There's another one called NCM, which is in Tesla or in LG Chem Storage. They are using another chemistries. So I'll give you one example why we use this chemistry instead of theirs. When BYD building a battery, or start to think or start to make batteries for storage for electric vehicles, we believe safety is always number one. We should be when we're making the battery, that's the priority, and we should never compromise on the safeties. So there's one a short video I'm gonna show you. Is we're doing what we call the penetration test, like this one, and it makes the internal cells become short-circuiting, and you will see the difference between different chemistries or different battery cells. So our battery will be the second, and the last one will be our new generation of the BYD Blade battery. So I'm gonna play the video. The first one is the battery cells that's used for Tesla cars or the LGs. So what you will see, if actually internal short circuiting happened, the NCM batteries the temperature goes to 500 degrees Celsius right away, and it will have a explosion. And the second one will be the BYD battery, like the battery box, the cells we're using right now, the LFP battery. So you will see there's no major explosions. The temperature only goes to 200 degrees Celsius, which is, we believe, this is safer than the other chemistry combinations, and we believe that's the good results. And temperature changes, no explosions, and it's 100% safe. And this is one of the you cannot get these batteries from anyone else in the world right now. Okay. So just give you a little demonstration. Why we're saying our battery is safe. And the next thing is this. Every batteries, they have a different standards, certifications, everything. So there's one certificate I would say this is really hard to get for the batteries, which is the VDE 2510-50. This is the car battery standards, but we already have on our stationary battery storage, which is really hard. Basically, make sure your batteries, from different tests, they need to meeting a different, requirements. Then they can offer you this certificate, which is our stationary battery is already okay to putting on the cars. So that's why we're saying we want to make the battery as safe as possible, and we never compromise on the safeties. Next video I'm going to show you is the compatibility testing, and also the production line for actually making the product. So you saw the battery cells, but this time we'll show you how the battery is assembled, the weldings, everything in our factory.
Hi everyone, welcome to BYD. This is the BYD battery box dedicated inverter compatibility center. Let's have a look, come on. Here you can see all the compatible inverters that are compatible with the BYD battery box premium series. Our testing lab has 3 labs. Our battery box R&D center has 3 labs: the performance, the environmental, and the Compatibility Testing Center. Here, the battery box inverter compatibility center, you can see all the battery, the inverter brands is undergoing the testing with the battery box premium series. The battery box premium series is designed to match all the compatible inverter brands in terms of the functionality and the compatibilities. At the initial stage, our engineering team discussed and exchanged ideas with the expert from the inverter manufacturers, which includes the protocol communication, safety control strategies, peak power, and etc. You can see they're also here today doing some testing now. During the whole process, our engineering team started a series of the hash tests with each one of the inverters, which includes the charging and discharging power, the overload testing, and the off-grid test, single phase or three phase, and others. Our testing team are monitoring the systems every day, and you can see the battery information is showing here. All the testing we have done here is to guarantee the package is reliable in every conditions and also in every single installations. Not only from the compatibility testing level, but also from the product design, product definitions, and also the after-sales service. The whole process we have done is to make sure the whole package is reliable and also is working properly. The compatibility testing will be officially announced only when both parties agree there's no issues, and then we can make sure the whole package is working properly in the field. We have also recording all the testing and history information in the computer, and you can see the information history is now from when the battery box premium was initially tested. We would be thrilled to have you on a visit to BYD, and we can show you around. Welcome everyone to the BYD battery box factory. Here's our battery box premium family module production. As you can see, we bring the cell to you here for this assembly. And the whole assemblies, one of the key points is the modular and the weldings. So we have got automatic welding machine here, as you can see, and to make sure the whole system is very reliable. Here is the battery box mass tracking systems. For every cell and every module of our battery box, we can track during the whole process. All the components has been implemented in our systems. Okay, let's go to the next stop. Here is our testing area. For every single component of the battery box, before we ship to you, it's already 100% tested in our factory. Here we'll do all the different testing for the electronic parts and the battery modules, and to make sure everything is working properly, I will put in the box, I will deliver to you. Okay, let's go to the next stop. My dear friend, that is all for the factory. We really hope to see you in the near future. Thank you. Bye.
Okay. Can you still hear me? Hello?
Yep.
Yeah. So that's a short video that's actually made by my colleague Joey. He's the sales manager for the Australia and New Zealand market. And just as you can see in qualities, when we actually manufacture the battery or assemble the battery cells, is all the tests, all the the production line is top in the market. So that's what we believe. We're not the cheap batteries, and how much you paid for that battery is how much you get from that. And another feature of the BYD battery besides the quality is the flexibility, which is you see in this for installations. So you can use our high voltage battery with the old Fronius Simo hybrid, or the new Gen24, just having the new Gen24 itself. Or if the customer have existing Fronius solar inverters, you can just get the Gen24 AC coupled to or retrofit to the existing system. So basically, the customer have option to put additional panels on the new inverters as well. On the flexibility, this is so on the operating temperature range. So from -10 to +50, so a quite wide range, and also IP55 enable the batteries can be installed outside or inside. The next thing is we said you can extend the system at any time. What we means is the customer can starting with the system with small as a 5.1 kilowatt hour for the high voltage system, and they can, when their family grow bigger and they want to getting more battery storage to lower the electricity bill, so they can get up to 10 kilowatt hours, and then they decide, okay, we're gonna try a new electric vehicles, then they need more power from the batteries to charge their cars quickly, so which they will need additional power of the batteries and get up to around 20 kilowatt hours. So with the extend at any time is actually means if you purchase the battery system today, so we're gonna offer either a same battery extend or a similar service to help the customer to expand the system within the 10 years warranty. So one example is we have a first installations back in 2016, and we still offer the extend service for those products that's in 2021, and we believe we're going to continue offering this until we release a next generation of the product and stop producing the old products. But unlike our competitors, in probably 1 to 2 years, they're going to release a new batteries, and then they're going to stop on the old one, and there's no way to expand. Okay, this just show you not just the high voltage. On the low voltage, we have a capacity range is from 4 to roughly 1 megawatt hour, so covered almost all the commercials and the residentials. We have a application for every product for every applications. What we means is support on-grid backup, emergency backup, and off-grid. But for the high voltage range with Fronius, you only have the on-grid grid tie system or the backup system. So the next one is the high performance. What I mean by high performance, I'm gonna show you in the next, probably in the next few slides, is for some backup, they only can do, like 5 kilowatts or 7 kilowatts. But for our systems, is you have a ranges from 5 to 10 kilowatt, and actually for Fronius, it's a 9.1 kilowatt maximum. Which gives you, why you need a high powers. Probably won't need at the moment, but when you have electric vehicles, you don't want to charge your batteries, take 10 hours to just slowly charge your cars. You want to charge them quick. Maybe you just park your car, in the afternoon and need to drive them, during the night. So you need to charge them quickly. You need a high performance. And the second one will be, energy trading market will be the next big thing for the solar market. And customer have an option to trade their battery storage, energies back to the grid and to get the payment from that. So we believe high performance systems give them high chances, during the peak hours, they can get more, financial return from the same system. On the efficiencies, so this is one important test in Europe, and you can see the Fronius new SIMO Gen 24 without BYD battery box is ranked #1 on the efficiencies. And there's other, our battery with the different inverters or, different batteries. But in general, why efficiency makes, difference? Why there's a high voltage battery, high voltage inverters? Simple is that the high batteries is share the same DC bus with the inverters, which generally they are high voltage, and you don't have the DC to DC conversions anymore, and they can charge the battery directly. So in this way, you save the efficiency there. And the second, if the whole system is very efficient, for example, a 95% efficiency compared to something like 80% percent efficiencies, which means when you charge the battery 100%, and you can get a 95% out from that battery, so after from to depleted the battery. So it's probably only 15%. About why this makes huge difference is you can consider your battery is at 10 kilowatt hours, and the 15% is roughly 1.5 kilowatt hour for one cycle. And if you multiply with 365 days, 15 years of the battery design life, and it will make consider the local electricity bills. It could be couple of thousands dollars difference in actually 10 to 15 years. So that's actually just a high efficiency system will give you a lot of difference in over 10 years or 15 years. Okay, now we're gonna cover the products, the HVS and the HVM. And this will be the new products we offer to the New Zealand market this year. And you can see there's two different types. The HVIs stand for high voltage small, and the M stand for medium. So one difference is you can get the HVM to a larger system. That's what medium means, and the small is only a small system. But the another thing is the HVS system. First, they give you a very small starting point, and second, they are more powerful than the HVM batteries. So, which means you probably get the similar size of the HVS 7.7, and it can charge or discharge your batteries around like 6 kilowatt. But compared to, you need at least HVM 13.8 to have a similar power output, which means for customer they need charge their battery quickly, discharge their battery quickly, they need to consider this, or they just want a small system to start with. For customer, don't really care, they just need to smooth their load consumptions or load shiftings. They can consider the HVM battery, which is a slightly cheaper and have a capability goes to a higher storage. So 3 inverters are compatible with the Fronius, the single-phase primal, 3-phase SIMO, and old SIMO hybrid 3-phase. So because the battery is a DC coupled, we don't really care, is a single-phase or 3-phase. As long as the inverter is matching up with your design, then that's fine. We have a compatibility test. It doesn't mean, sorry. It doesn't mean every combinations with a Fronius and BYD battery is compatible. So you can download this list from our website, or from the BYD website as well, or from the test from the distributors. And the next one, this is from Fronius datasheet, and you can tell, this is really handy. They tell you from which combinations and the maximum power output that is. For example, the HVS 10.2 only compatible with the SIMO 3-phase, and if you actually get the SIMO 10.0, the maximum charge and discharge power is a 9 kilowatt from the batteries, which is much more than what Tesla offers, a 5 kilowatt, or the LG Chem 7 kilowatt. So, and this is not even, if the inverters keep improving or getting more features, the same battery, we can actually doing more than that. But at the moment, we're limiting that to 9 kilowatt. Okay, this is where when you purchase the batteries, it's just very simple. It comes with 2 different boxes. One is a top and base, and one is the battery modules. And you can see there's no cable between each ones, and they're using a quick connector. So which means when you actually do the installations, is just plug and play. So you don't need connecting any wires between each batteries, and just simply connecting them and put the screws fixed between each battery modules. And there's also wall mount to get the battery, against the wall. This is not freestanding. On the connection area, so I'll give you more detailed photos. So for the connections, what you need to do is majorly a 10 mil cable connecting to the positive and negative. And the communication cable, you have two options. One is our quick connector. You can put the wires in directly, or you want to remake the plug and connecting to the RS-485 to Fronius. So other ports is either for parallel, for internet, or is for different inverters. And the last but not least, there's a ground cable required as well. The reason why you need a 10 mil cable, this is the AS/NGS 5139 standards, the battery installation standards. It require, because we have a 63 amp circuit breaker, which means if you use a double insulated 10 mil battery cable and connecting to Fronius, you don't need additional isolation device or circuit breakers in the middle between the Fronius and the batteries. And you can use our built-in one for both overcurrent protection and the isolation device. So this is accessible by the end user as well. So after you finish the installation, then you need to commission the batteries. A similar process, compared to the inverter company. I think you guys did this a lot. So it's from a cell phone app, and you need download the firmware and update the firmware, time and date, inverter Fronius, very straightforward, which model you are doing. Is that on-grid or backup, or is that single phase, three phase? So submit the configurations, and that's it. So, but we think we need to do more on the current app. We should let the installer, basically having more features from that one app. And we're bringing a B-Connect 2.0 this month. So what we added, some key features like real-time data reading. So you can see or the end user can see the data locally. Just download the app, connecting to the batteries, logging as end user, and they can see the real-time voltage, temperatures, basically, all the battery detail information if they want to see it. And the next thing is the history events. So, for batteries is when something actually happened, and the customer doesn't want to, connecting their system to the internet, because, for some manufacturers, they just, checking your system, do changes without the end user know what happened. So what we're gonna offer is the end user have a capability to check what happened on the system, and also for the installer to troubleshoot the system, to know, what's going on the battery side. And there's a one-click service, which means you click this button, that will send the data to our server. So you gave BYD authorizations to actually checking your system. And also we provide a service guideline, provide you step-by-step troubleshooting the system. So what's going on? Is that new installations, you see the fault message, how to troubleshoot, how to fix the issue. We have a service guide to provide. Sorry. Last but not least is for the extensions. This is a little bit tricky. Like if you're putting a new modules to the existing system, you need to make sure the original batteries is discharged or charged to 20 to 30% SOC. This is a little bit tricky. But basically, if you're having any issues or you're gonna put a new battery into the system, you can either follow our instructions or simply give us a phone call. Let us know. We're gonna telling you what you need to do, and generally, within 1 hour, you're gonna finish the installations. this is the new combiner box we're offering, but this is optional. So you don't need this one if you don't want to do this. So when you parallel multiple batteries, and sorry, this is IP55, and so basically what this optional combiner box offer is they have internal DC bus, 2 of them, one for positive, one for negative. So that's it. So it just joins all the DC connections from different towers, and you can simply just make your own DC buses and just get one DC output connecting to the inverters. So you don't have to purchase this combiner box, but if you want to make your life easier, we offer that as an option units. The next one is the rewards program. So this is similar for everyone else offering at the to the market. So we have our big partner rewards program. You can register when you have new installations, and when you install more, you get different levels, and different level give you more benefits. For example, a higher level of servicing. And for example, there's some gifts we're gonna send, the end of year or half of the year, we're gonna send to our basically level 2 and level 3 customers. Those are our websites, and if you want to basically check more information, we have all our data sheets, installation manual, everything. And if you want to know more about our BYD high voltage or even low voltage batteries, on-grid, off-grid, please feel free to send us an email. We can do a one-on-one training, especially for the Fronius customer, or simply give us a phone call to the Australian hotline number. And that's the end of my presentation. And really, thanks for the opportunities. That's from Taspac and Fronius. Today gave us the time to deliver this to you guys. And if you have any questions, please let me know. Thanks.
Awesome. Thanks, Jad. If anyone's got any questions,
But it's okay if you guys don't have any questions, but actually when you decide to do some battery storage cells, you can always let us know. We can give you more detailed information either on the sales part or on the technical troubleshooting or installations, whatever you guys need.
I've got one question. I've done a couple of the LVL modules.
Might you speak up, but
Can you get that okay?
Microphones in the
Yes, yeah.
Yeah, I've done a couple of LVL modules, and it's got an external BMS with an internet connection. So does do we need still, is it still recommended to have an internet connection direct to the battery?
Okay, it's optional. So as I mentioned, the internet is always optional, and we don't look at your system unless you tell us to do. So we won't push any firmwares or anything unless, okay, you said there's some issues, just simply send us the email and the serial number. We can take a look, or update any firmwares if you guys need. So it is totally optional. If you don't connecting the internet, as I mentioned, the new apps, the end user also have an opportunity or has the tool to checking the system, checking the events, or downloading any data they can send to the installer, and you can pass to us. We can take a look. So the internet is not mandatory, but if you're feeling this is really remote site and we need to, if anything happened, we need to know, then yeah, we highly recommend that you get the internet connected. So in this way, it's hassle-free for the end users.
Awesome. Thanks, Jay. Are there any other questions? Very good. Thanks, mate. We'll sign off there.
Okay.
Thank you very much for your time.
Yep. Thanks, James.
Cheers.
Yeah.
Thank you.
Thank you. Alrighty, and that's all we have on the agenda for today.
No, we've got to do a finish off.
Oh, sorry. One more.